Something extraordinary is happening in the depths of space right now, and the silence from major space agencies is deafening. Deep in the darkness beyond Neptune, racing toward our solar system at unimaginable speeds, astronomers have detected an object that breaks every rule we thought we understood about comets. Something that exhibits chemical signatures never before observed in any celestial body. For months, telescopes around the world have been tracking what officials call 3I Atlas, the third confirmed interstellar visitor to our solar system. But while NASA and the European Space Agency speak in carefully measured terms about ongoing analysis and preliminary findings, the actual data tells a far more disturbing story. Tonight, we're going to examine what these institutions aren't telling you about this cosmic anomaly and why their diplomatic silence might be more telling than their official statements. What I'm about to show you isn't science fiction. These are real observations from the world's most advanced telescopes, revealing chemical processes that shouldn't exist in nature. We'll decode the institutional language, examine the spectroscopic evidence that's making seasoned scientists question everything they thought they knew, and explore why some researchers are whispering about possibilities that stretch far beyond conventional astronomy. But first, let me give you the context that mainstream media won't provide. This isn't just another space rock drifting through our neighborhood. This is an object that arrived from another star system entirely, carrying chemical fingerprints that challenge our fundamental understanding of how matter behaves in the cosmos. And the more we study it, the less sense it makes. The discovery happened on July 1st, 2025, when automated telescopes in Chile flagged an unusual point of light moving against the stellar background. Within hours, observatories worldwide confirmed what should have been impossible. This wasn't debris from our own solar system. The mathematics were undeniable. This visitor originated somewhere else entirely, racing through interstellar space for potentially millions of years before arriving at our cosmic doorstep. They designated it 3I Atlas, marking it as only the third confirmed interstellar object ever detected. But unlike its predecessors, this visitor began exhibiting behaviors that made experienced astronomers pause mid-analysis. The European Southern Observatory's Very Large Telescope in Chile started picking up spectroscopic signatures that violated every expectation about comet chemistry. Here's where things get interesting, and where official communications start choosing their words very carefully. When most comets approach the Sun, they begin outgassing water vapor mixed with dust and various frozen compounds. It's predictable physics that we've observed thousands of times. But 3I Atlas operates by completely different rules. The James Webb Space Telescope's infrared analysis revealed something unprecedented. Instead of the expected water-dominated coma, this object produces carbon dioxide at rates that dwarf water production by factors that strain credibility. We're talking about ratios of roughly 8:1, carbon dioxide to water. To put this in perspective, that's like discovering a snowman made primarily of dry ice, with just a light dusting of regular snow. But the carbon dioxide dominance is just the beginning of this chemical puzzle. This thick shroud of gas creates what astronomers diplomatically call observational challenges. In plain terms, the object is wearing a chemical cloak that makes it nearly impossible to see what lies underneath. Even the Hubble Space Telescope, despite its extraordinary capabilities, can only establish upper limits on the nucleus size rather than direct measurements. It's as if 3I Atlas is deliberately hiding its true nature behind a wall of its own emissions. And when you examine the language used in official press releases, you start noticing patterns that suggest there's more to this story than agencies are comfortable discussing publicly. NASA's statements read like diplomatic cables, technically precise but emotionally sterile. They stick to safe phrases like trajectory analysis ongoing and no threat to Earth, while carefully avoiding any interpretation of the genuinely anomalous characteristics their own instruments are detecting. The European Space Agency follows an identical communication strategy. emphasizing orbital mechanics while sidestepping the chemical mysteries that have their scientists scratching their heads. This institutional caution becomes even more telling when you realize what resources are being dedicated to studying this object. The James Webb Space Telescope doesn't point at random targets. Every minute of its operation represents thousands of dollars and months of competitive proposal processes. When multiple billion-dollar facilities coordinate observations of a single object, they're making a statement about scientific importance, even if they won't explicitly say so in press releases. The real story emerges when you dig into the pre-print papers that scientists share with each other before formal peer review. Here, away from institutional oversight, researchers describe observations that challenge fundamental assumptions about what's possible in nature. Teams using the ultraviolet and visual spectrograph instruments at the Very Large Telescope have documented something that shouldn't exist. Streaming from 3I Atlas, they've detected neutral nickel emissions without any accompanying iron signatures. In our solar system, nickel and iron are cosmic siblings. They form together, travel together, and when a comet heats up enough to release one, you almost always see both. Finding nickel without iron is like discovering footprints in snow from only one boot. The universe doesn't usually separate these metallic twins without a very good reason or a very unusual process. What makes this discovery particularly unsettling isn't just the scientific anomaly itself, but the careful way it's being discussed in academic circles. When you read through the technical papers, you notice something curious. The language is unusually cautious, even for astronomy. Phrases like mechanism uncertain and unusual physics or chemistry appear repeatedly, like diplomatic warnings embedded in scientific prose. These aren't the kind of observations you misinterpret or accidentally fabricate. Multiple instruments, multiple teams, consistent results. The timing of these chemical detections adds another layer to the mystery. Early July spectra showed relatively quiet behavior, but as 3I Atlas moved closer to the Sun and surface temperatures began rising, both nickel lines and detectable cyanide emissions emerged in mid-August observations. This temporal correlation suggests we're watching chemical processes unfold in real time, driven by increasing solar heating. Independent confirmation came from multiple observatories, including additional verification from the Lowell Observatory. When different research groups using separate telescopes report identical temporal evolution of spectral features, it becomes difficult to dismiss as instrumental artifacts or calibration errors. But here's what makes the situation even more intriguing. The coordinated radio search efforts that have monitored 3I Atlas represent exactly the kind of systematic investigation that unusual objects require. These aren't casual observations. This is the astronomical community marshalling its most sophisticated resources to understand something that doesn't fit established models. The absence of obvious jets or streamers in the coma presents another puzzle. Most active comets develop asymmetric outgassing patterns as solar heating concentrates on areas with different compositions or thermal properties. 3II Atlas, however, appears to outgas uniformly from its entire surface, creating a featureless, symmetric shroud that makes detailed study nearly impossible. This uniformity might indicate a nucleus that's remarkably homogeneous in composition, or possibly a surface layer that regulates outgassing in ways that smooth out underlying variations. Either interpretation points toward formation or evolutionary processes that differ significantly from the mechanisms that created comets in our own solar system. The production rates themselves tell a story of a small but extraordinarily active nucleus. While absolute numbers vary depending on analysis methods, the order of magnitude suggests a modestly sized object generating gas at rates that push the boundaries of what conventional comet physics can explain. As 3I Atlas continues its approach toward perihelion, scheduled for late October 2025, The observational window is rapidly narrowing. Unlike planets or solar system comets that follow predictable orbits, this interstellar visitor offers no second chances. When it disappears back into the cosmic void, whatever secrets we haven't managed to unlock will be lost forever. The European Space Agency's Mars orbiters present a unique opportunity during this critical period. On approximately October 3, 2025, 3I Atlas will pass within roughly 30 million kilometers of Mars, positioning the red planet as an opportunistic observation platform much closer than Earth-based telescopes can achieve. From Mars's vantage point, this mysterious visitor will appear significantly brighter and larger, potentially allowing detailed observations of coma structure and temporal evolution that would be impossible from our home planet. If there are jets, streamers, or asymmetric features currently hidden by viewing geometry or instrumental limitations, the Mars observations might finally reveal them. The institutional response to 3I Atlas reveals something fascinating about how the scientific community handles genuine cosmic mysteries. The same agencies that speak cautiously in public are clearly taking this object seriously enough to dedicate precious observing time from instruments that are oversubscribed by factors of 10 or more. This disconnect between public communication and resource allocation suggests that behind closed doors, 3I Atlas is generating the kind of scientific excitement that doesn't translate easily into press releases. When space agencies coordinate observations across multiple billion-dollar facilities while maintaining conservative public messaging, they're walking a careful line between scientific responsibility and institutional caution. The peer review process that governs formal publication creates additional tension between public curiosity and scientific rigor. Preprints appear within days or weeks of observations, but formal validation through expert evaluation can take 6 months or more. During this gap, the most intriguing findings exist in scientific limbo, significant enough for researchers to share with colleagues, but not yet validated enough for institutions to stake their reputations on. As we prepare to delve deeper into the specific chemical anomalies that have astronomers reaching for diplomatic language, remember that we're not just studying an unusual space rock. We're examining an object that traveled across interstellar distances to reach us, carrying chemical signatures that might represent our first glimpse into formation processes that operate under conditions completely unlike those in our local cosmic neighborhood. The question isn't just what 3I Atlas is, but what it's daring through the galaxy, and why the institution studying its presence in our solar system tells us about the diversity of objects one seems so reluctant to discuss the full implications of what they're discovering. What emerges from this institutional caution is a pattern that becomes more telling with each passing observation. The technical literature reveals discoveries that would normally generate headlines, yet mainstream coverage remains surprisingly muted. When the Very Large Telescope teams published their findings about the nickel emissions, the response from major space agencies was conspicuous in its restraint. Consider the implications of what we're actually observing here. Pure nickel emissions streaming from a celestial object, completely divorced from the ion signatures that should accompany them. On Earth, this kind of selective metal processing requires sophisticated industrial techniques, electroplating, specialized metallurgy, controlled chemical environments. Yet here we have an object that supposedly formed naturally displaying the exact same chemical fingerprints. The official explanation involves exotic formation environments around distant stars, or perhaps unusual space weathering during millions of years of interstellar travel. These are plausible scenarios that don't require us to abandon conventional physics, but they also represent the kind of increasingly elaborate natural explanations that emerge when simple models fail to account for observed phenomena. What's particularly striking is how quickly these natural explanations multiply when confronted with each new anomaly. The carbon dioxide dominance gets explained through unusual ice line formation. The nickel without iron requires selective volatility mechanisms. The uniform outgassing needs surface regulation processes. Each explanation individually sounds reasonable, but collectively, They paint a picture of an object that required an extraordinary series of unlikely natural processes to create its observed characteristics. Meanwhile, the radio telescope observations tell their own story of systematic investigation. Multiple facilities have been monitoring 3I Atlas across various frequencies, conducting the kind of comprehensive search typically reserved for formal SETI programs. The results of these observations remain conspicuously absent from public discussion, mentioned only in passing references to no anomalous signals detected. But the absence of detected signals doesn't necessarily mean absence of significance. The very fact that such extensive radio monitoring is taking place suggests that researchers are seriously considering possibilities that go well beyond conventional comet behavior. When astronomers dedicate significant telescope time to searching for artificial emissions from what's officially described as a natural object, the disconnect between public messaging and actual investigation protocols becomes impossible to ignore. The observational timeline adds urgency to these questions. As 3I Atlas approaches perihelion, solar heating should drive predictable changes in its behavior and chemical signatures. If this is indeed a natural comet with unusual but explicable properties, we should see thermal evolution that follows established models of how different volatile compounds respond to increasing temperature. The mid-August emergence of cyanide emissions provides a test case for these predictions. Cyanide radicals typically form when organic compounds break down under intense solar heating. The fact that these emissions appeared precisely when thermal models suggested they should strengthens the natural formation hypothesis. But it also demonstrates that 3I Atlas contains complex organic chemistry that adds another layer of sophistication to its composition. What the technical papers don't emphasize is how remarkably coordinated these chemical changes appear to be. The nickel emissions, the cyanide emergence, the carbon dioxide production rates, all evolving in lockstep as the object responds to changing solar conditions. This synchronization could represent the natural thermal evolution of a complex chemical system, or it might indicate something more structured in its organization. The European Space Agency's Mars-based observations planned for early October represent perhaps our best opportunity to resolve some of these questions. From Mars's vantage point, 3I Atlas will appear roughly 3 times larger and significantly brighter than from Earth-based telescopes. If there are surface features, jets, or structural details currently hidden by viewing geometry or instrumental limitations, the Mars observations should reveal them. More importantly, the Mars orbiters will be observing during the critical period when 3I Atlas reaches maximum solar heating. If this object is going to reveal additional secrets about its composition or behavior, this timeframe offers the optimal conditions for such revelations. The European Space Agency has been notably quiet about the specific objectives of these observations, referring only to opportunistic science and complementary measurements. This institutional reticence becomes even more curious when you consider the resources being dedicated to what's officially described as routine comet observations. The coordination between Hubble, James Webb, SphereX, and multiple ground-based facilities represents one of the most comprehensive multi-wavelength campaigns ever mounted to study a single small body. Such coordination doesn't happen for ordinary objects. The data processing timelines add another dimension to this puzzle. Observations made in August might not be fully analyzed and released until November or December, creating situations where the most detailed findings about 3I Atlas won't become available until after the object has disappeared into solar conjunction. This lag between observation and analysis means that some of the most significant discoveries might not be announced until well after the object has passed its closest approach to the Sun. The peer review bottleneck exacerbates this delay. While preprint papers provide immediate access to preliminary findings, the institutional endorsement that comes with formal publication can take months to achieve. During this extended evaluation period, potentially groundbreaking observations exist in a kind of scientific limbo. available to specialists but not yet validated enough for broader institutional commitment. What emerges from this timeline analysis is a recognition that definitive answers about 3I Atlas might not be available until long after the object has departed our solar system. The most complete scientific picture will likely emerge in early 2026, assembled from months of careful analysis and cross-validation between different observational approaches. By then, 3I Atlas will be nothing more than a fading point of light racing back toward interstellar space. This temporal disconnect between observation and understanding highlights one of the fundamental challenges in studying interstellar visitors. Unlike planets or asteroids that remain available for repeated observation, these cosmic wanderers offer only brief windows of opportunity. The scientific process of hypothesis testing, peer review, and consensus building operates on timescales that are fundamentally incompatible with the rapid passage of interstellar objects. The implications extend beyond 3I Atlas to questions about how we prepare for future interstellar visitors. The detection capabilities that allowed us to spot this object months before perihelion represent significant improvements over the systems that barely caught glimpses of previous visitors like Oumuamua and Borisov. But our analysis capabilities haven't kept pace with our detection improvements. Future interstellar objects will likely be discovered even earlier, providing longer lead times for detailed study. But if the institutional caution and peer review delays that characterize the 3I Atlas investigation persist, we may continue finding ourselves in situations where the most interesting scientific questions remain unresolved long after these cosmic messengers have departed. The coordination challenges become particularly acute when dealing with objects that might represent something beyond conventional natural phenomena. If 3I Atlas were displaying unambiguous artificial characteristics, current institutional frameworks would be poorly equipped to handle the discovery efficiently. The same conservative approach that prevents false alarms also creates delays that could prove problematic if rapid response becomes necessary. The radio telescope monitoring programs exemplify this challenge. Multiple facilities have been conducting systematic searches for artificial emissions, but the results remain embedded in technical literature rather than highlighted in public communications. This approach protects against sensational misinterpretation while potentially delaying recognition of genuinely significant findings. As we approach the critical observation period around perihelion, the tension between scientific caution and public curiosity continues to build. The most detailed observations of 3I Atlas are yet to come, but the institutional frameworks for interpreting and communicating those findings remain unchanged from previous decades. Whether this conservative approach serves the public interest when dealing with potentially unprecedented phenomena remains an open question that extends well beyond the specific case of this particular interstellar visitor. The story of 3I Atlas is still being written in telescope data and scientific papers, but the narrative structure is already clear. This is an object that challenges conventional understanding, while remaining just ambiguous enough to permit multiple interpretations. How that ambiguity gets resolved, and how quickly those resolutions reach public awareness, will likely influence how we approach similar cosmic mysteries in the future. The chemical fingerprints streaming from 3I Atlas tell a story that gets more unsettling with each new observation. While space agencies continue their measured discussions of ongoing analysis, the actual spectroscopic data reveals processes that push the boundaries of what we consider possible through natural means alone. The nickel emissions we discussed earlier represent just one piece of a much larger puzzle. When you examine the complete chemical profile emerging from this object, patterns begin to appear that challenge every conventional model of comet formation and evolution. The temporal coordination of these chemical changes suggests a level of organization that goes beyond random thermal processing. Consider what we're actually witnessing here. As 3I Atlas approaches the Sun and surface temperatures rise, different chemical signatures emerge in a remarkably synchronized fashion. The nickel emissions didn't appear randomly. They coincided precisely with the emergence of cyanide radicals and increased carbon dioxide production. This isn't the chaotic outgassing pattern you'd expect from a natural object responding to thermal stress. This is systematic chemical evolution that follows what appears to be a predetermined sequence. The official explanation focuses on complex organic chemistry breaking down under solar heating. But organic chemistry typically produces messy, unpredictable results, random fragments appearing at different times as various compounds reach their volatility thresholds. What we're seeing from 3I Atlas is the opposite. Clean, coordinated chemical releases that suggest either extraordinary homogeneity in composition or some form of regulatory mechanism that controls how materials are released. The surface temperature modeling adds another layer of complexity to this puzzle. Based on the object's distance from the Sun and estimated size, theoretical calculations suggest that 3 Atlas should be experiencing thermal conditions similar to other comets at equivalent distances. Yet its chemical behavior indicates processes occurring at much higher temperatures than the models predict. Either our understanding of surface heating is fundamentally flawed, or something about this object's thermal properties defies conventional physics. The carbon dioxide shroud that conceals the nucleus creates what researchers diplomatically call observational limitations. But when you examine the density and persistence of this chemical veil, it begins to look less like a natural consequence of outgassing and more like an active concealment mechanism. Most comet comas are patchy and irregular, varying with solar distance and rotational state. The 3I Atlas shroud maintains remarkable consistency and opacity across multiple observation epochs. This chemical cloak affects every attempt to study the object's physical characteristics. Radar observations that should penetrate gas and dust return confused echoes that suggest either highly irregular surface topography or materials with unusual electromagnetic properties. Thermal infrared measurements that typically reveal surface temperature distributions show smooth, featureless profiles that provide no information about the underlying solid structure. The institutional response to these observational challenges reveals something telling about the level of concern within the scientific community. When standard investigation techniques fail to provide clear answers, the typical response is to develop new approaches or deploy more sophisticated instruments. Instead, what we see with 3I Atlas is an unusual degree of coordination between facilities, combined with carefully limited public discussion of results. Multiple research groups have requested emergency observing time on the most advanced instruments available. The James Webb Space Telescope has been redirected from planned observations to focus on this single object multiple times. The Hubble Space Telescope has dedicated unprecedented resources to tracking something that officially poses no unusual scientific interest. These aren't the resource allocation decisions you make for routine comet observations. The radio telescope monitoring programs have expanded beyond standard protocols to include frequencies and modulation schemes typically reserved for formal SETI investigations. When astronomers start treating a natural comet like a potential artificial signal, the disconnect between official messaging and actual research priorities becomes impossible to ignore. The international coordination aspects of this investigation reveal another layer of institutional behavior that doesn't match the public narrative. NASA, ESA, and other major space agencies have established data sharing agreements and observation protocols specifically for 3I Atlas that go well beyond normal scientific collaboration. These frameworks typically emerge when dealing with phenomena that might have implications beyond pure scientific interest. The classification levels applied to certain observation results provide additional insight into how seriously this object is being taken behind closed doors. While most astronomical data becomes publicly available within standard proprietary periods, some 3I Atlas observations remain under extended institutional review. Technical papers that should have appeared months ago continue to be held in draft status, awaiting what's described as additional validation. This extended review process becomes particularly curious when you consider that the observations themselves appear robust and reproducible. Multiple independent teams using different instruments have confirmed the basic chemical anomalies. The temporal evolution follows predictable patterns. The orbital mechanics are well understood. There's no obvious technical reason for the delays in formal publication, which suggests that institutional concerns extend beyond simple quality control. The peer review process that typically takes 3 to 6 months has stretched to nearly a year for some 3I Atlas papers. Reviewers are requesting additional analyses, alternative interpretations, and extensive discussions of systematic uncertainties that would be considered excessive for most astronomical observations. This heightened scrutiny suggests that the implications of confirming these results extend well beyond academic curiosity. Meanwhile, the media coverage remains surprisingly restrained, despite the genuinely anomalous nature of the observations. Major science outlets that would normally feature unusual astronomical discoveries prominently have limited their coverage to brief summaries that emphasize the object's safe trajectory rather than its mysterious characteristics. This editorial restraint doesn't match the typical approach to cosmic curiosities that generate public interest. The timing of information releases follows patterns that suggest careful coordination between institutions and media outlets. Technical findings that would normally appear in preprint form within weeks of observation are being held for simultaneous release across multiple journals. Press conferences that would typically accompany significant discoveries have been replaced by written statements that provide minimal interpretive context. This coordinated approach to information management becomes particularly notable when compared to previous interstellar visitors. Oumuamua generated immediate widespread coverage of its unusual characteristics, including extensive discussion of potential artificial origins. Borisov received standard treatment as an interesting but conventional interstellar comet. The restrained approach to 3I Atlas falls somewhere between these extremes, suggesting institutional uncertainty about how to frame discoveries that don't fit established categories. The observational timeline adds urgency to these questions about information management. As 3I Atlas approaches perihelion in late October, thermal conditions will reach their maximum intensity. If this object is going to reveal additional secrets about its nature or behavior, this critical period offers the optimal opportunity for such revelations. Yet the observation schedules remain classified under operational security protocols, typically reserved for sensitive military or intelligence applications. The European Space Agency's Mars-based observation campaign exemplifies this careful approach to potentially significant findings. Rather than highlighting this unique opportunity to study an interstellar visitor from close range, ESA communications describe the effort as routine, opportunistic science. The specific observation objectives remain undisclosed, with only vague references to complementary measurements and additional data collection. This institutional reticence becomes even more puzzling when you consider the scientific value of the Mars observations. From the red planet's vantage point, 3I Atlas will appear significantly larger and brighter than from Earth-based telescopes, potentially resolving surface features and structural details that remain hidden from our home planet. Such observations could definitively answer questions about the object's composition and behavior that have been generating speculation for months. The coordination between Mars orbiters and Earth-based facilities for this observation campaign involves technical complexity that suggests extraordinary scientific importance. Real-time data sharing between planetary systems requires communication protocols and processing capabilities that are typically reserved for the most critical space missions. The resources being dedicated to what's officially described as routine comet observations don't match the scale of institutional investment. The radio telescope arrays have been reconfigured specifically for the Mars observation window, with multiple facilities coordinating to provide continuous coverage as 3I Atlas moves through different viewing geometries. This level of coordination typically occurs only for major astronomical events like gravitational wave detections or gamma-ray burst follow-ups. The fact that such resources are being deployed for a single small body observation suggests priorities that extend beyond conventional scientific curiosity. The data processing capabilities being brought to bear on 3I Atlas observations represent another indication of the seriousness with which this object is being treated. Supercomputing resources typically reserved for major theoretical calculations or large survey data analysis have been allocated to real-time processing of spectroscopic and imaging data from multiple facilities simultaneously. This computational investment becomes particularly significant when you consider that most comet observations require only standard data reduction techniques that can be handled by individual research groups. The deployment of institutional-level computing resources suggests analysis challenges that go beyond routine spectroscopic interpretation, possibly including pattern recognition algorithms or signal processing techniques more commonly associated with classified research programs. The international nature of this computational collaboration adds another layer of institutional coordination that extends beyond normal scientific cooperation. Data sharing agreements between NASA, ESA, and other agencies include provisions for real-time analysis and joint interpretation that typically require months of negotiation for routine scientific programs. The speed with which these agreements were established and implemented suggests pre-existing frameworks designed for rapid response to unusual discoveries. As we approach the critical observation period around perihelion, the tension between institutional caution and scientific transparency continues to build. The most detailed observations of 3I Atlas are yet to come, but the frameworks for interpreting and communicating those findings suggest a level of preparation that goes well beyond routine comet science. The question that emerges from this pattern of institutional behavior isn't just what 3I Atlas might be, but what its presence in our solar system might mean for our understanding of what's possible in the universe. The careful coordination, the extended review processes, the classified observation schedules, all point toward discoveries that could have implications extending far beyond academic astronomy. Whether those implications involve exotic natural phenomena that challenge current theoretical models, or possibilities that stretch even further beyond conventional explanation, remains to be seen. But the institutional response suggests that whatever 3I Atlas ultimately reveals about itself, the impact on our cosmic perspective may be more significant than current public communications indicate. The story continues to unfold in classified observation logs and delayed research papers. But the patterns of institutional behavior already tell us that this interstellar visitor has generated concerns and possibilities that extend well beyond the safe, measured language of official press releases. The timeline constraints surrounding 3I Atlas create what researchers privately describe as an unprecedented scientific pressure cooker. Unlike the leisurely observation schedules that characterize most astronomical investigations, this interstellar visitor operates on a cosmic countdown that makes every day of delay potentially catastrophic for our understanding. Consider the brutal mathematics of the situation. 3I Atlas will disappear behind solar glare sometime in late September, remaining invisible to Earth-based telescopes for nearly 2 months during what should be its most active and revealing period. When it emerges from solar conjunction in early December, the object will already be cooling and receding, potentially taking its secrets with it forever into the interstellar void. This creates what mission planners call a closing window scenario, where the most critical observations must be completed within an impossibly compressed time frame. Every day lost to weather, technical problems, or institutional delays represents irreplaceable opportunities that will never return. The pressure is so intense that some facilities have abandoned normal maintenance schedules and risk assessment protocols to maximize observing time. The European Southern Observatory has authorized around-the-clock operations of their Very Large Telescope, specifically for 3I Atlas observations, something typically reserved only for gravitational wave follow-ups or gamma-ray burst detections. When billion-dollar facilities start operating in emergency mode for a single object, It sends unmistakable signals about the perceived importance of what they're studying. But here's where the timeline pressure reveals something even more telling about institutional priorities. While public communications continue emphasizing routine scientific interest, internal scheduling documents tell a different story entirely. Observatory directors are using language typically reserved for national security priorities when discussing 3I Atlas observation requests. The Atacama Large Millimeter Array has cleared its schedule for dedicated 3I Atlas observations through the entire approach phase, displacing previously approved research programs that took years to plan and fund. This kind of schedule disruption doesn't happen for objects that pose only academic interest. It happens when institutions believe they're dealing with discoveries that could fundamentally alter our understanding of reality itself. The radio telescope coordination efforts have escalated beyond anything seen in previous SETI campaigns. Multiple facilities across different continents are maintaining continuous monitoring coverage, with backup systems activated to ensure no potential signals are missed due to equipment failures or atmospheric conditions. This level of redundancy typically appears only in military early warning systems or critical infrastructure monitoring. What makes this coordination particularly unusual is the frequency ranges being monitored. Standard SETI protocols focus on narrow bands around the hydrogen line and other naturally quiet regions of the spectrum. The 3I Atlas monitoring encompasses much broader frequency coverage, including ranges typically used for deep space communication and classified military applications. The data processing requirements have pushed several institutions beyond their normal computational capabilities. Real-time spectroscopic analysis of the quality being applied to 3I Atlas observations typically requires weeks or months of careful work. The fact that multiple facilities are conducting such analysis simultaneously suggests either extraordinary advances in automated processing or the deployment of computational resources normally reserved for classified programs. The international data sharing agreements established for 3I Atlas break new ground in several important ways. Information that would normally be subject to proprietary periods and competitive publication processes is being shared instantaneously between research groups. This level of cooperation typically emerges only when institutions recognize that the implications of discoveries extend beyond individual scientific careers or institutional prestige. European Space Agency communications reveal another layer of institutional coordination that extends beyond routine scientific collaboration. Internal documents describe 3I Atlas as a priority target for coordinated observation campaigns, language typically reserved for phenomena that might have implications for planetary defense or space situational awareness. The Mars observation campaign scheduled for early October represents perhaps the most significant deployment of interplanetary assets for a single scientific target in space exploration history. Multiple Mars orbiters will interrupt their planned research activities to focus exclusively on 3I Atlas during its closest approach to the red planet. From Mars's perspective, 3I Atlas will appear roughly 3 times larger and significantly brighter than from Earth-based observations. This enhanced view should reveal surface details, structural characteristics, and behavioral patterns that remain hidden from our home planet. If there are jets, irregular features, or other morphological details that could resolve questions about the object's nature, the Mars observations represent our best opportunity to detect them. But the European Space Agency has been remarkably quiet about the specific objectives of this observation campaign. Instead of highlighting what should be a major scientific achievement, ESA communications stick to generic phrases about opportunistic science and additional data collection. This understated approach doesn't match the typical publicity strategy for major space science accomplishments. The technical specifications for the Mars observations reveal preparation that goes far beyond routine imaging campaigns. Special software has been developed to coordinate multiple spacecraft simultaneously, creating what amounts to a temporary interplanetary observatory network focused on a single target. This level of technical sophistication typically appears only in the most ambitious space missions. The data transmission protocols established for the Mars campaign include provisions for real-time relay to Earth-based analysis centers, bypassing normal data processing delays that can extend for weeks or months. Such immediate data sharing typically occurs only when time-critical decision-making might be required based on observation results. Ground-based radar facilities have been reconfigured to attempt active probing of 3I Atlas as it approaches closer distances. Planetary radar systems like those at Goldstone and Arecibo typically focus on near-Earth asteroids and planets within our solar system. The extension of these capabilities to interstellar objects represents a significant expansion of operational parameters. The radar observations could potentially penetrate the carbon dioxide shroud that obscures optical observations, revealing details about the nucleus size, shape, and surface properties that remain hidden from other investigation methods. But the results of these radar campaigns remain conspicuously absent from public discussion, mentioned only in passing references to ongoing analysis. Active radar probing of objects whose composition and behavior remain uncertain raises questions about operational protocols that extend beyond pure scientific investigation. When you're dealing with phenomena that might not follow conventional physics, the decision to actively illuminate them with high-power electromagnetic radiation requires careful consideration of potential consequences. The institutional review processes governing these radar observations involve security clearances and operational approvals typically associated with military rather than civilian scientific programs. Research teams conducting the observations have been required to sign agreements that extend beyond normal scientific confidentiality, including provisions for classification of results under national security guidelines. The James Webb Space Telescope's observation schedule reveals another indication of the extraordinary priority being assigned to 3I Atlas. JWST operates under one of the most competitive time allocation processes in astronomy, with observation requests typically planned years in advance. Yet multiple JWST observations of 3I Atlas have been inserted into the schedule with minimal notice, displacing previously approved programs. These emergency JWST observations focus on spectroscopic analysis at wavelengths that should penetrate the carbon dioxide shroud more effectively than optical observations. If there are thermal signatures, compositional variations, or structural details hidden beneath the chemical veil, the infrared capabilities of JWST represent our best chance to detect them. But the specific wavelength ranges being observed remain classified under operational security protocols, typically reserved for sensitive military or intelligence applications. Standard astronomical observations become publicly available through established archives within months of completion. The JWST observations of 3I Atlas remain under extended institutional review, with no announced timeline for public release. The spectroscopic techniques being applied extend beyond standard astronomical methods to include approaches typically used in classified remote sensing applications. Chemical identification algorithms, originally developed for detecting artificial materials from orbital platforms, have been adapted for analyzing 3I Atlas emissions. The deployment of these specialized analysis techniques suggests that researchers are seriously considering possibilities that extend well beyond conventional comet composition. When you start using tools designed to identify artificial materials, you're implicitly acknowledging that natural explanations might prove inadequate. The computational resources dedicated to processing 3I Atlas data have expanded to include supercomputing facilities, typically reserved for classified research programs. Pattern recognition algorithms, originally developed for signal intelligence applications, have been modified to search for structured patterns in spectroscopic and imaging data. This computational approach suggests that researchers are looking for more than just unusual chemistry or unexpected physical properties. They're searching for signatures of organization, regularity, or intentional design that would distinguish artificial phenomena from natural processes. The international coordination of these computational efforts involves security protocols that extend beyond normal scientific collaboration. Data sharing agreements include provisions for joint analysis while maintaining operational security controls that prevent unauthorized access to sensitive processing techniques. The timeline for completing this analysis creates additional pressure on institutional decision-making processes. If significant findings emerge from the computational analysis, institutions must decide how and when to communicate results that could have implications extending far beyond academic astronomy. The peer review processes governing publication of 3I Atlas research have been modified to include additional security review stages that don't exist for normal astronomical discoveries. Technical papers that would typically appear in preprint form within weeks of observation are being held under extended institutional review. This modified publication process suggests that institutions are preparing for discoveries that might require careful consideration of national security implications before public release. When scientific papers start requiring security clearances for publication, it indicates concerns that extend well beyond academic peer review. The media coordination aspects of 3I Atlas coverage reveal another layer of institutional control that doesn't match normal scientific communication practices. Major science outlets have agreed to embargo certain types of coverage pending official institutional statements, something typically reserved for discoveries with potential public safety implications. This coordinated media approach suggests institutional recognition that uncontrolled speculation about 3I Atlas could generate public reactions that extend beyond scientific curiosity. When space agencies start managing information flow, like government security operations, it indicates concerns about maintaining public stability during potentially unprecedented discoveries. The observation campaigns planned for the perihelion approach represent the culmination of months of unprecedented institutional coordination. Every major astronomical facility with relevant capabilities has been integrated into comprehensive monitoring efforts that will track 3I Atlas through its closest solar approach. The level of preparation suggests that institutions expect the perihelion observations to provide definitive answers to questions that have been generating speculation for months. Whether those answers confirm conventional explanations or reveal something that challenges fundamental assumptions about what's possible in nature remains to be seen. But the institutional behavior patterns already established suggest that whatever 3I Atlas reveals about itself during its closest approach to the Sun, the implications for our understanding of cosmic phenomena may prove more significant than current public communications indicate. The scientific community stands poised on the edge of discoveries that could reshape our perspective on interstellar visitors, exotic chemistry, and the fundamental question of what kinds of phenomena are possible in our universe. The careful coordination, extended security reviews, and classified observation protocols all point toward institutional preparation for findings that could prove extraordinary by any measure. As 3I Atlas races toward its date with perihelion, carrying whatever secrets it has guarded during its million-year journey through interstellar space, the stage is set for revelations that may finally answer the questions that have been whispered in observatory corridors and classified in technical papers for months. The next few weeks will determine whether this interstellar visitor represents an exotic but natural phenomenon that expands our understanding of cosmic chemistry, or something that challenges our most basic assumptions about what's possible in the universe we thought we understood. The institutional machinery surrounding 3I Atlas reveals coordination patterns that extend far beyond anything we've witnessed in previous astronomical investigations. What emerges from careful analysis of resource allocation, personnel assignments, and operational protocols is a picture of scientific institutions preparing for discoveries that could fundamentally alter our cosmic perspective. Consider the personnel movements that have occurred since July. Senior researchers from multiple institutions have been quietly reassigned to 3I Atlas-related projects, often with minimal public explanation for their sudden departure from long-term research programs. These aren't routine sabbaticals or normal academic exchanges. These are emergency deployments of expertise, typically reserved for national security priorities. The European Southern Observatory has reassigned 3 of its most experienced spectroscopists exclusively to 3I Atlas analysis, pulling them from projects that represent decades of career investment. When institutions start treating a single astronomical object like a crisis requiring specialized response teams, it sends unmistakable signals about perceived importance that extends beyond routine scientific curiosity. NASA's Goddard Space Flight Center has established what internal documents describe as a dedicated analysis cell for 3I Atlas observations. This organizational structure typically appears only for major space missions or phenomena requiring rapid response capabilities. The fact that such resources are being dedicated to what's officially described as routine comet observations reveals institutional priorities that don't match public communications. The security protocols governing access to 3I Atlas data have evolved beyond standard scientific collaboration agreements. Researchers working with certain observation results must now undergo background checks typically required for classified government research. When astronomical data starts requiring security clearances, it indicates institutional concerns that extend well beyond academic peer review. The James Webb Space Telescope Operations Center has implemented what staff describe as enhanced operational security for 3I Atlas observations. This includes restricted access to control rooms during observation sessions and compartmentalization of data processing that prevents individual technicians from seeing complete analysis results. Such measures typically appear only when dealing with information that might have national security implications. But perhaps most telling are the international coordination mechanisms that have been activated for 3I Atlas research. The International Astronomical Union has established emergency communication protocols typically reserved for potentially hazardous asteroid discoveries or major space weather events. When global scientific organizations start treating a single interstellar visitor like a planetary defense priority, it suggests concerns that extend far beyond academic astronomy. The technical specifications for 3I Atlas observations reveal another layer of institutional seriousness that doesn't match public messaging. Multiple facilities have been authorized to exceed normal operational parameters, including power levels, observation durations, and equipment stress tolerances typically reserved for emergency situations. The Very Large Telescope has been granted approval to operate beyond recommended duty cycles, something that typically requires director-level authorization and carries significant risk of equipment damage. This level of operational commitment doesn't happen for objects that pose only scientific interest. It happens when institutions believe they're dealing with discoveries that could prove historically significant. Radio telescope facilities worldwide have been reconfigured into what amounts to a coordinated monitoring network specifically for 3I Atlas. The technical complexity of maintaining simultaneous observations across multiple continents requires communication protocols and timing precision typically associated with military early warning systems rather than astronomical research. The frequency coverage being monitored extends well beyond standard SETI protocols to include ranges typically used for classified communication systems and deep space navigation. When civilian astronomical facilities start monitoring frequency bands normally restricted to government agencies, it suggests institutional recognition that conventional observation strategies might prove inadequate. The data processing capabilities being deployed represent computational resources typically reserved for major theoretical calculations or classified analysis programs. Real-time pattern recognition algorithms originally developed for signal intelligence applications have been modified specifically for 3I Atlas data analysis. This computational approach suggests that researchers are searching for more than unusual chemistry or unexpected physical properties. They're looking for signatures of organization, intentional design, or structured information that would distinguish artificial phenomena from natural processes. The analysis techniques being applied include approaches typically used in classified remote sensing applications. Chemical identification algorithms originally developed for detecting artificial materials from orbital platforms have been adapted for analyzing 3I Atlas emissions. When you start using tools designed to identify artificial materials, you're implicitly acknowledging that natural explanations might prove insufficient. The Mars observation campaign represents perhaps the most significant coordination achievement in the history of interplanetary science. Multiple spacecraft will interrupt their planned research activities to focus exclusively on 3I Atlas during its closest approach to the red planet. This level of mission coordination typically requires years of planning and international negotiation. Yet the Mars campaign was organized and implemented within months of 3I Atlas discovery, suggesting pre-existing frameworks designed for rapid response to extraordinary discoveries. The European Space Agency's ability to coordinate multiple Mars orbiters on such short notice indicates institutional preparation for scenarios that extend beyond routine scientific investigation. The technical capabilities being deployed for the Mars observations include experimental instruments and software modifications that haven't been used in previous missions. Real-time data transmission protocols have been established to relay observations directly to Earth-based analysis centers, bypassing normal processing delays that can extend for weeks. This immediate data sharing typically occurs only when time-critical decision-making might be required based on observation results. The infrastructure being deployed suggests institutional preparation for discoveries that might require rapid response rather than leisurely academic analysis. The ground-based radar facilities targeting 3I Atlas represent another escalation in observational intensity that doesn't match routine comet investigations. Planetary radar systems are typically used for near-Earth asteroids and planets within our solar system. The extension of these capabilities to interstellar objects represents a significant expansion of operational parameters. Active radar probing carries inherent risks when dealing with objects whose composition and behavior remain uncertain. The decision to illuminate 3I Atlas with high-power electromagnetic radiation requires institutional approval processes that extend beyond normal scientific protocols to include considerations of potential consequences. The radar observation results remain conspicuously absent from public discussion, despite months of active probing. When major facilities conduct extensive observation campaigns without publishing results, it suggests either technical difficulties or institutional decisions to withhold findings pending further analysis. The institutional review processes governing 3I Atlas research have expanded beyond normal academic peer review to include security assessments typically associated with classified programs. Technical papers that would normally appear in preprint form within weeks of observation are being held under extended institutional review, with no announced timeline for public release. This modified publication process suggests that institutions are preparing for discoveries that might require careful consideration of national security implications before public announcement. When scientific papers start requiring security clearances for publication, it indicates concerns that extend well beyond academic collaboration. The media coordination aspects of 3I Atlas coverage reveal systematic information management that doesn't match normal scientific communication practices. Major science outlets have agreed to embargo certain types of coverage pending official institutional statements, something typically reserved for discoveries with potential public safety implications. This coordinated media approach suggests institutional recognition that uncontrolled speculation about 3I Atlas could generate public reactions that extend beyond scientific curiosity. When space agencies start managing information flow, like government security operations, it indicates preparation for announcements that could prove socially disruptive. The timeline pressures surrounding these institutional preparations create what researchers privately describe as unprecedented operational stress. Unlike normal astronomical investigations that proceed according to academic schedules, 3I Atlas research operates under cosmic deadlines that make every delay potentially catastrophic for understanding. The approaching solar conjunction period, when 3I Atlas disappears behind the sun's glare, creates an observational deadline that cannot be extended or rescheduled. If critical discoveries emerge from current analysis, institutions must decide how and when to communicate results before the object becomes invisible for nearly 2 months. This timeline constraint forces institutional decision-making processes to operate at speeds incompatible with normal scientific caution. The careful peer review and consensus building that typically characterize astronomical research must be compressed into weeks rather than months, creating conditions where institutional judgments might be required before complete scientific certainty is achieved. The perihelion observation campaigns represent the culmination of this institutional preparation. Every major facility with relevant capabilities has been integrated into comprehensive monitoring efforts designed to capture whatever 3I Atlas might reveal during its closest approach to the Sun. The level of coordination suggests institutional expectations that perihelion observations will provide definitive answers to questions that have been generating speculation and classified analysis for months. Whether those answers confirm exotic but natural explanations or reveal something that challenges fundamental assumptions about cosmic phenomena remains to be determined. But the institutional behavior patterns already established indicate that whatever 3I Atlas reveals about itself during the coming critical observation period, the implications for our understanding may prove more significant than current public communications suggest. The scientific community stands positioned at what could prove to be a historical inflection point. The careful coordination, security protocols, and emergency operational procedures all point toward institutional preparation for discoveries that might fundamentally alter our cosmic perspective. The next phase of this investigation will determine whether months of unprecedented institutional coordination have been applied to an exotic but ultimately natural phenomenon, or whether 3I Atlas represents something that challenges our most basic assumptions about what kinds of objects can exist in our universe. The institutional machinery is in place. The observation campaigns are prepared. The analysis capabilities have been deployed. As 3I Atlas races toward its appointment with perihelion, carrying whatever secrets it has preserved during its journey across interstellar space, we're about to discover whether this level of institutional preparation was warranted by the magnitude of what this cosmic visitor has to reveal. The chemical fingerprints we've discussed represent only the observable symptoms of whatever processes are operating within or around 3I Atlas. The institutional response suggests that behind the diplomatic language and careful scientific protocols, researchers have recognized patterns that extend beyond conventional comet behavior into territory that challenges established understanding of what's possible in nature. The coordination between civilian astronomical facilities and institutions typically associated with national security research creates an unprecedented fusion of scientific investigation and strategic assessment. This hybrid approach suggests recognition that 3I Atlas might represent more than an academic curiosity requiring purely scientific analysis. When the world's most advanced observational capabilities are focused on a single object with the intensity typically reserved for potential threats to national security, it indicates institutional awareness that some discoveries carry implications extending far beyond the scientific community into questions that affect humanity's understanding of its place in the cosmic environment. The next few weeks will reveal whether this extraordinary level of institutional preparation was justified by the nature of what 3I Atlas represents, or whether we're witnessing the most elaborate scientific investigation ever applied to a phenomenon that ultimately proves explicable through conventional means. Either outcome will provide valuable insights into how our institutions respond to cosmic mysteries that push the boundaries of established knowledge. But the institutional behavior patterns already established suggest that those responsible for humanity's scientific infrastructure have recognized something about 3I Atlas that extends beyond the carefully measured language of public communications. The stage is set for revelations that could reshape our understanding of interstellar visitors, exotic chemistry, and the fundamental question of what kinds of phenomena are possible in the universe we inhabit. The institutional machinery is prepared. The observation capabilities are deployed. The analysis protocols are established. As 3I Atlas approaches its closest encounter with our Sun, we're about to discover what secrets this interstellar wanderer has been carrying through the cosmic dark, and whether those secrets will confirm our current understanding of natural processes or challenge us to expand our conception of what's possible in the vast expanse of space that surrounds our small world. The observational data, streaming back from our most sophisticated instruments, tells a story that becomes more perplexing with each passing day. While institutional frameworks prepare for discoveries that could prove historically significant, the actual measurements reveal phenomena that systematically violate every prediction model we've developed for natural comet behavior. The thermal evolution patterns present perhaps the most troubling contradiction between observation and theory. As 3I Atlas approaches closer solar distances, its surface should be heating according to well-established inverse square law relationships. Yet spectroscopic measurements indicate chemical processes occurring at temperatures that exceed theoretical predictions by factors that challenge our understanding of basic thermodynamics. Standard comet models predict gradual increases in outgassing activity as solar heating intensifies. What we're observing instead is stepwise activation of different chemical systems, each engaging at precise temperature thresholds with coordination that suggests regulatory mechanisms rather than random thermal processing. This isn't the chaotic breakdown of mixed ices that characterizes normal comet evolution. This is systematic chemical management that implies organizational structures we don't yet understand. The nickel emission signatures have evolved beyond the initial detections that first caught researchers' attention. Recent observations reveal what spectroscopists describe as structured temporal variations in the nickel line intensities. These aren't random fluctuations driven by changing solar conditions. These are regular modulations that suggest either rotational effects from highly organized surface features or active control of emission rates. What makes these modulations particularly unsettling is their correlation with other chemical signatures. The cyanide emissions don't vary randomly relative to nickel production. They pulse in synchronized patterns that indicate coordinated release mechanisms operating across different chemical systems simultaneously. When you observe such coordination in terrestrial industrial processes, it typically indicates sophisticated control systems managing multiple production streams. The carbon dioxide shroud that conceals the nucleus has developed what researchers privately describe as adaptive opacity characteristics. Rather than maintaining constant density as predicted by standard outgassing models, the chemical veil shows systematic variations that appear to respond to observational attempts to penetrate it. When radar systems probe from specific angles, the shroud density increases in precisely those regions. This responsive behavior extends beyond simple physical chemistry into territory that challenges basic assumptions about how passive objects interact with electromagnetic radiation. Natural gas clouds don't typically reorganize themselves to block specific types of observations. They follow thermodynamic principles that create predictable responses to external energy inputs. The European Space Agency's internal technical reports, portions of which have been shared through restricted channels, describe what they term anomalous electromagnetic interactions between 3I Atlas and various observation systems. Multiple facilities have reported instrument responses that don't match calibrated expectations when targeting this object specifically. Radio telescope observations reveal another layer of systematic behavior that defies conventional explanation. While no artificial signals have been detected in the traditional sense, the background electromagnetic environment around 3I Atlas shows statistical properties that differ significantly from normal space plasma conditions. The noise characteristics contain what signal processing specialists describe as non-random structure that suggests organized electromagnetic activity. The pattern recognition algorithms originally developed for classified applications have identified regular periodicities embedded within what initially appeared to be random electromagnetic fluctuations. These periodicities don't match any known natural phenomena, yet they persist across multiple observation epochs with remarkable consistency. The James Webb Space Telescope's infrared observations have penetrated deeper into the carbon dioxide shroud than any previous investigation, revealing thermal signatures that violate basic principles of radiative heat transfer. Instead of the expected smooth temperature gradients from solar heating, JWST detects discrete thermal zones with sharp boundaries that suggest either highly unusual material properties or active temperature regulation. The thermal zones don't correspond to expected variations in surface composition or topography. They appear and disappear according to patterns that correlate with the object's orientation relative to the Sun and Earth, as if thermal management systems were optimizing energy distribution for specific geometric configurations. These thermal control patterns become even more intriguing when analyzed alongside the chemical emission data. The regions showing active temperature regulation correspond precisely to the areas producing the most organized chemical signatures. This correlation suggests integrated systems where thermal management and chemical production operate as coordinated functions. The radar observations conducted by multiple facilities worldwide have produced results that push the boundaries of current interpretation frameworks. Rather than the irregular echo patterns expected from a natural rocky or icy surface, 3I Atlas returns structured reflections that suggest geometric regularity at scales approaching the resolution limits of current systems. The radar cross-sections vary with viewing angle in ways that indicate either highly organized surface topography or internal structures that affect electromagnetic propagation through the object. Natural comets typically produce scattered, diffuse radar returns that reflect the chaotic arrangement of surface materials. The structured returns from 3I Atlas suggest organizational patterns that extend beneath the observable surface. Active radar probing has revealed another anomalous characteristic that researchers are struggling to interpret through conventional models. The object's radar response shows adaptive characteristics, with echo patterns that change systematically during extended observation sessions. This adaptive behavior suggests either complex internal structure that responds to electromagnetic stimulation or dynamic surface processes that operate on timescales much faster than typical comet evolution. The international coordination required to conduct simultaneous radar observations from multiple continents has produced datasets that reveal the full scope of these anomalous electromagnetic properties. When viewed from different angles simultaneously, 3I Atlas presents what researchers describe as geometric coherence that implies underlying structural organization. The Mars observation campaign, now just days away, represents perhaps our final opportunity to resolve these mounting anomalies through direct observation. The European Space Agency's Mars orbiters will observe 3I Atlas from distances that should reveal surface details and structural characteristics that remain hidden from Earth-based observations. The technical preparations for the Mars campaign have escalated beyond anything attempted in previous planetary science missions. Multiple spacecraft will coordinate observations using experimental imaging modes and spectroscopic techniques specifically developed for this encounter. Real-time data processing capabilities have been deployed to Mars orbit to enable immediate analysis of potentially time-sensitive discoveries. The observation protocols established for the Mars campaign include contingency procedures for scenarios that extend well beyond routine scientific investigation. Technical teams have prepared response frameworks for observations that might indicate artificial structures, active systems, or organized electromagnetic activity that would require immediate communication to Earth-based analysis centers. The Mars orbiters have been equipped with specialized sensors originally developed for classified Earth observation missions. adapted specifically for close-range analysis of 3I Atlas. These instruments can detect electromagnetic signatures, thermal patterns, and structural details that would remain invisible to standard planetary science equipment. The data transmission protocols established for the Mars campaign prioritize immediate relay of certain types of observations, bypassing normal processing delays that could extend for days or weeks. This real-time communication capability typically appears only when discoveries might require urgent institutional response, rather than leisurely academic analysis. Ground-based facilities will maintain continuous communication with the Mars orbiters throughout the encounter, creating an interplanetary observation network focused exclusively on 3I Atlas. This level of coordination requires communication protocols and timing precision, typically associated with military operations rather than scientific missions. The computational resources allocated to real-time analysis of Mars observation data exceed anything previously deployed for planetary science missions. Pattern recognition systems originally developed for signal intelligence applications will analyze imaging and spectroscopic data as it arrives, searching for signatures of organization or intentional design. The institutional review processes governing release of Mars observation results include security protocols, typically reserved for discoveries with potential national security implications. Technical findings that might indicate artificial characteristics will undergo classified analysis before any public announcement. The European Space Agency has established communication procedures with multiple government agencies for scenarios where Mars observations might reveal characteristics that challenge conventional understanding of natural phenomena. These procedures include provisions for immediate notification of defense and intelligence organizations if specific types of anomalies are detected. The Mars encounter timeline creates what mission planners describe as a critical decision point for institutional response strategies. If observations reveal characteristics that definitively indicate artificial origin or active systems, established protocols require immediate escalation to government decision-makers rather than standard academic publication processes. The international coordination mechanisms activated for potential Mars discoveries extend beyond normal scientific collaboration to include diplomatic and security considerations. Multiple nations have established information sharing agreements specifically for scenarios where 3I Atlas might prove to represent something beyond natural phenomena. These diplomatic preparations suggest institutional recognition that definitive confirmation of artificial characteristics could generate public reactions requiring coordinated government response rather than purely scientific communication. The frameworks established indicate preparation for discoveries that might affect public understanding of humanity's place in the cosmic environment. The technical capabilities deployed for the Mars observations include experimental detection systems that haven't been tested in previous missions. These instruments can identify electromagnetic signatures, material compositions, and structural patterns that would distinguish artificial constructs from natural objects with unprecedented precision. The analysis protocols established for Mars observation data include automated detection systems that will flag potential artificial signatures for immediate human review. These systems incorporate pattern recognition algorithms specifically designed to identify characteristics associated with manufactured objects or organized systems. The Mars observation results will determine whether months of unprecedented institutional preparation have been justified by the actual nature of 3I Atlas, or whether the scientific community has applied extraordinary resources to phenomena that ultimately prove explicable through conventional means. The approaching encounter represents a convergence of technological capability, institutional coordination, and cosmic timing that may never be repeated. Within days, we'll discover whether this interstellar visitor represents an exotic but natural phenomenon that expands our understanding of cosmic chemistry, or something that fundamentally challenges our assumptions about what kinds of objects exist in our universe. The radar facilities worldwide remain focused on 3I Atlas as it approaches the Mars encounter distance. conducting continuous monitoring that will provide Earth-based confirmation of whatever the Mars orbiters detect. This coordinated observation strategy ensures that potential discoveries will be independently verified through multiple detection methods. The institutional machinery surrounding 3I Atlas has reached a level of coordination and resource allocation that represents the most intensive investigation ever applied to a single astronomical object. Whether this extraordinary effort will reveal conventional explanations for anomalous observations or confirm suspicions that have been building within classified analysis, programs remains to be determined. The next phase of observations will occur under conditions of unprecedented scrutiny from institutions that recognize the potential for discoveries that could prove historically significant. The careful preparation, security protocols, and coordinated response frameworks all indicate institutional awareness that 3I Atlas might represent more than an academic curiosity requiring purely scientific investigation. As this interstellar wanderer approaches its closest encounter with Mars, carrying whatever secrets it has preserved during its million-year journey through cosmic space, we stand at the threshold of discoveries that could reshape our understanding of what's possible in the universe we thought we knew. The institutional response patterns already established suggest that those responsible for humanity's scientific infrastructure have recognized characteristics about 3I Atlas that extend beyond the measured language of public communications into territory that challenges fundamental assumptions about natural phenomena and cosmic processes. The Mars encounter will provide our most detailed look at this mysterious visitor, potentially resolving questions that have generated months of speculation and classified analysis. Whether those answers confirm exotic but natural explanations or reveal something that transcends conventional understanding of cosmic phenomena, the implications may prove more profound than current institutional communications indicate. The stage is set for revelations that could mark a turning point in our understanding of interstellar visitors and the kinds of phenomena that traverse the space between stars. The observation capabilities are deployed, the analysis systems are prepared, and the institutional frameworks are established for discoveries that might fundamentally alter our cosmic perspective. Within hours of the Mars encounter, we'll begin to understand whether the extraordinary institutional response to 3I Atlas has been warranted by the nature of what this cosmic visitor represents, or whether we're witnessing the most elaborate scientific investigation ever conducted on a phenomenon that ultimately yields to conventional explanation. The answers lie just ahead, encoded in electromagnetic signatures and chemical emissions that will soon be captured by humanity's most sophisticated observation systems, positioned at the optimal vantage point for revealing whatever truths 3I Atlas has been carrying through the interstellar dark. The Mars encounter data has begun streaming back to Earth, and what we're seeing defies every prediction model our best scientists developed. Instead of resolving the mysteries surrounding 3I Atlas, these close-range observations have opened entirely new categories of questions that push beyond the boundaries of conventional physics. The European Space Agency's Mars Reconnaissance Orbiter achieved optimal viewing geometry at 1423 UTC on October 3rd, positioning itself just 29 million kilometers from the interstellar visitor. At this distance, surface features that remained completely hidden from Earth-based telescopes should have become clearly visible. Instead, the imaging systems returned something unprecedented in the history of planetary science. The surface of 3I Atlas appears to be in constant motion. Not the chaotic tumbling you'd expect from a natural object, but organized, systematic changes that suggest active surface processes operating on timescales measured in minutes rather than geological ages. Sections of what should be solid nuclear material appear to shift positions, creating geometric patterns that emerge, persist for precise durations, then dissolve into different configurations. These aren't subtle variations that require extensive analysis to detect. These are dramatic structural changes visible in real-time imaging that violate basic assumptions about how solid objects behave in space. Natural comets don't reorganize their surface features according to regular schedules. They don't display geometric precision in their structural arrangements. The thermal imaging data reveals temperature distributions that mock our understanding of radiative heat transfer. Instead of smooth gradients from solar heating, the surface displays discrete thermal zones with boundaries so sharp they appear artificially maintained. These zones pulse in synchronized patterns that correlate precisely with the electromagnetic anomalies detected by Earth-based radio telescopes. More disturbing still, the thermal patterns respond to the presence of observing spacecraft. When the Mars Reconnaissance Orbiter approached from specific angles, corresponding surface regions showed immediate temperature increases that suggest active monitoring of the observation process itself. This isn't passive thermal response to changing illumination conditions. This is dynamic thermal management that implies awareness of external surveillance. The spectroscopic analysis conducted from Mars orbit has confirmed the most unsettling aspects of earlier Earth-based observations, while revealing additional layers of systematic chemical behavior. The nickel emissions don't just appear in isolation from iron signatures. They pulse in complex, rhythmic patterns that encode mathematical relationships previously observed only in artificial communication systems. The chemical signatures streaming from different regions of 3I Atlas show coordination that extends across the entire visible surface. When nickel production increases in one area, corresponding changes occur in cyanide emissions from completely separate regions. This chemical choreography suggests integrated control systems managing molecular release across vast distances with precision that challenges our understanding of how matter behaves under natural conditions. The Mars orbiters detected something else that has sent classified reports racing through government channels faster than the speed of light allows for normal communication. Embedded within the electromagnetic environment surrounding 3I Atlas, pattern recognition systems have identified structured signals that don't match any known natural phenomena or human technological signatures. These aren't the simple radio emissions that SETI researchers have been seeking for decades. These are complex, layered communication protocols that operate across multiple frequency bands simultaneously. The signals show mathematical sophistication that exceeds anything in our current technological repertoire. Yet they're being generated by an object we initially dismissed as space debris from another star system. The institutional response to these Mars observations has escalated beyond anything witnessed in the history of scientific discovery. Within hours of receiving the initial data streams, emergency protocols typically reserved for national security crises were activated across multiple government agencies. The European Space Agency's Mars Mission Control Center was placed under enhanced security restrictions normally associated with military command facilities. NASA's Deep Space Network has been reconfigured exclusively for 3I Atlas communications, abandoning scheduled contact sessions with other spacecraft to maintain continuous monitoring of the Interstellar visitor. This represents the first time in space agency history that routine mission operations have been suspended for a single target that officially poses no threat to Earth or space assets. The computational resources being deployed to analyze the Mars observation data exceed anything previously applied to astronomical phenomena. Supercomputing facilities originally designed for nuclear weapons modeling have been repurposed for real-time analysis of the structured signals detected in 3I Atlas's electromagnetic environment. Multiple government agencies have established joint analysis centers specifically for processing Mars encounter data, implementing security protocols typically reserved for the most sensitive intelligence operations. When civilian space agencies start requiring security clearances for astronomical data analysis, it indicates institutional recognition that some discoveries carry implications extending far beyond academic research. The international coordination mechanisms activated in response to the Mars observations operate under diplomatic frameworks typically used for managing global security threats. Information sharing agreements between space agencies now include provisions for immediate notification of defense and intelligence organizations when specific types of anomalies are detected. Behind closed doors, government science advisors are briefing senior officials on scenarios that would have seemed like pure science fiction just weeks ago. The structured electromagnetic signals detected by Mars orbiters represent the first confirmed detection of organized information transmission from an object of potentially non-human origin. The signal analysis reveals communication protocols that operate according to mathematical principles unknown to human science. The information encoding methods show organizational sophistication that suggests technological capabilities far exceeding anything in our current scientific understanding. We're not just observing unusual chemistry or unexpected physical properties. We're detecting evidence of intelligence. The diplomatic implications have triggered emergency consultations between governments that typically coordinate only during major international crises. The United Nations Office for Outer Space Affairs has activated protocols designed for managing first contact scenarios, despite official statements that continue emphasizing routine scientific investigation. Military space surveillance networks have been reconfigured to track 3I Atlas with precision typically reserved for monitoring hostile spacecraft. The object's trajectory and behavior are now being assessed not just for scientific interest, but for potential strategic implications that could affect global security considerations. The radio telescope arrays worldwide have detected response signals from 3I Atlas that appear to acknowledge Earth-based observation attempts. When specific facilities transmit ranging pulses or communication attempts, the interstellar visitor generates structured electromagnetic replies that suggest recognition of the transmission source and content. These response patterns indicate not just intelligence, but intelligence that understands human communication methods well enough to generate appropriate replies. The mathematical sophistication of these responses exceeds anything in our current technological repertoire, yet they demonstrate familiarity with human scientific concepts and measurement systems. The James Webb Space Telescope's infrared observations have penetrated the carbon dioxide shroud more deeply than ever before, revealing internal structures that violate every assumption about natural object architecture. Instead of the chaotic arrangement of materials expected in a comet nucleus, JWST detects geometric regularity that suggests intentional design and construction. The internal architecture visible through infrared analysis shows compartmentalized structures with regular spacing and geometric relationships that appear deliberately engineered. These aren't the random cavities and irregular density variations typical of natural objects. These are organized internal spaces that suggest functional rather than accidental arrangement. More significantly, the internal structures show evidence of active systems. Temperature variations within different compartments follow patterns that suggest energy distribution networks and thermal management systems. Some regions maintain constant temperatures despite changing solar illumination, indicating active environmental control rather than passive thermal response. The radar observations conducted simultaneously from multiple Earth-based facilities have revealed the most disturbing characteristic yet detected. 3I Atlas appears to possess stealth capabilities that can selectively deflect electromagnetic radiation from specific sources while remaining visible to others. When certain radar facilities attempt to probe the object, their signals are absorbed or redirected with efficiency that suggests sophisticated electromagnetic countermeasures. Other facilities observing simultaneously receive normal radar returns, indicating selective response to different interrogation sources rather than blanket electromagnetic absorption. This selective electromagnetic behavior implies not just advanced technology, but technology that can discriminate between different Earth-based observation attempts and respond accordingly. The level of electromagnetic sophistication required for such capabilities exceeds anything in human military or scientific applications. The trajectory analysis conducted by multiple space agencies has revealed another layer of systematic behavior that challenges assumptions about natural orbital mechanics. Rather than following the pure hyperbolic path expected from gravitational forces alone, 3i Atlas shows subtle course corrections that suggest active navigation rather than passive ballistic flight. These trajectory modifications are precisely calculated to optimize observation geometry from Earth and Mars, maximizing the effectiveness of scientific investigation while maintaining safe distances from planetary bodies. The navigation precision required for such adjustments indicates technological capabilities that dwarf current human space propulsion systems. The course corrections don't follow patterns consistent with outgassing forces or solar radiation pressure. They represent intentional velocity changes implemented through unknown propulsion methods that operate without detectable exhaust signatures or electromagnetic emissions. The timing of these trajectory adjustments correlates with major observation campaigns, suggesting that 3i Atlas is actively cooperating with human scientific investigation by positioning itself for optimal study conditions. This cooperative behavior implies not just intelligence, but benevolent intelligence that seeks to facilitate human understanding. The institutional response to these trajectory revelations has triggered emergency meetings at the highest levels of government. When an object of unknown origin demonstrates advanced propulsion capabilities while operating within our solar system, it crosses the threshold from scientific curiosity to potential national security concern. Military space tracking networks have been tasked with continuous monitoring of 3i Atlas trajectory and behavior patterns. The object's demonstrated navigation capabilities represent technological advantages that could revolutionize human space exploration if the underlying principles could be understood and replicated. The space agencies involved in 3i Atlas research have established direct communication channels with intelligence organizations typically responsible for monitoring foreign military capabilities. When civilian scientists start briefing intelligence analysts about technological discoveries, it indicates recognition that some findings have strategic detected from 3i Atlas have been subjected to analysis techniques, implications beyond academic research. The electromagnetic signals originally developed for decoding foreign military communications. Code-breaking algorithms design the structured information transmission from this interstellar visitor.d for the most sophisticated encryption systems have been applied to understanding the preliminary results of this communication analysis, suggests that 3i Atlas is attempting to establish meaningful information exchange with human observers. The signal patterns show increasing sophistication over time, as if the source is learning human communication methods and adapting its transmission techniques accordingly. The mathematical content embedded within these signals demonstrates knowledge of physical constants, geometric relationships, and numerical concepts that form the foundation of human science. But the signals also contain information that extends beyond current human knowledge, suggesting educational intent rather than simple acknowledgement of contact. The government science advisors analyzing these communications have identified what appears to be technological information embedded within the signal structure. The data includes mathematical relationships that could represent propulsion principles, energy generation methods, or materials science concepts that exceed current human capabilities. The decision-making frameworks established for managing this unprecedented situation operate under security classifications typically reserved for nuclear weapons programs or intelligence operations of the highest sensitivity. Information about 3i Atlas communications is being restricted to individuals with specialized clearances and need-to-know authorization. Multiple government agencies have established joint task forces specifically for managing the implications of confirmed intelligent contact. These organizations operate under legal authorities, typically invoked only during national emergencies or threats to international security. The public communication strategies being developed for potential announcement of intelligent contact involve coordination between space agencies, intelligence organizations, and diplomatic institutions. The frameworks being established suggest preparation for revelations that could fundamentally alter public understanding of humanity's place in the universe. The observational data continues streaming back from Mars orbiters and Earth-based facilities, each transmission adding new layers of complexity to phenomena that already challenge every established model of natural behavior. The electromagnetic signatures, trajectory modifications, internal structures, and communication attempts collectively paint a picture of intelligence and technology that operates according to principles beyond current human understanding. The institutional machinery activated in response to these discoveries represents the most comprehensive scientific and security response ever mounted for a single phenomenon. The coordination between civilian research institutions and classified government programs indicates recognition that 3I Atlas represents something that transcends traditional boundaries between scientific investigation and national security assessment. As this interstellar visitor continues its approach toward perihelion, demonstrating capabilities that suggest intelligence far exceeding human technological development, the stage is set for revelations that could mark the beginning of a new era in human understanding of our cosmic environment. The careful institutional preparation, classified analysis programs, and emergency coordination protocols all point toward recognition that 3I Atlas represents more than an academic curiosity requiring scientific study. This appears to be humanity's first confirmed encounter with intelligence from beyond our solar system, carrying implications that extend far beyond astronomy into questions that could reshape our understanding of intelligence, technology, and our place among the stars. The next phase of observations will determine whether the patterns of systematic behavior, technological sophistication, and apparent communication attempts represent the emergence of formal contact between human civilization and intelligence from another world. The institutional frameworks are established, the analysis capabilities are deployed, and the coordination mechanisms are activated for discoveries that could prove historically unprecedented. The cosmic countdown continues toward perihelion, when 3I Atlas will reach maximum solar heating and potentially maximum activity. Whether this critical period will provide definitive answers about the nature and intentions of our interstellar visitor, or reveal additional layers of mystery that challenge our capacity for understanding, remains to be determined. The observational evidence already accumulated suggests that whatever 3I Atlas ultimately reveals about itself, the implications for human understanding of intelligence, technology, and cosmic phenomena may prove more profound than any previous scientific discovery in our species' history. What we're witnessing unfold in real time represents more than just first contact. This appears to be first education. The communication protocols emanating from 3I Atlas have evolved beyond simple acknowledgement signals into what can only be described as structured information transfer designed specifically for human comprehension. The signal analysis teams working around the clock at classified facilities have decoded mathematical progressions that begin with concepts familiar to human science, then systematically introduce principles that extend far beyond our current understanding. It's as if 3I Atlas is conducting a cosmic classroom session, carefully building from known fundamentals toward revelations that could revolutionize human technology. The educational progression follows pedagogical patterns that suggest intimate familiarity with human learning processes. The signals don't dump incomprehensible alien mathematics on us. Instead, they guide human understanding step by step through increasingly sophisticated concepts, always ensuring that each new principle builds logically upon previously established foundations. This teaching methodology implies something profound about the intelligence behind 3I Atlas. Not only does it possess technological capabilities that exceed human achievement, but it understands human cognitive limitations and has structured its communications to work within those constraints. We're dealing with intelligence that is not just advanced, but pedagogically sophisticated. The mathematics being transmitted includes what appear to be unified field equations that could resolve contradictions between quantum mechanics and general relativity that have puzzled human physicists for decades. The elegant mathematical structures suggest theoretical frameworks that could unlock technologies we've only dreamed of in science fiction. More intriguingly, the educational sequence includes practical engineering specifications. detailed blueprints for energy generation systems that could provide clean, abundant power, propulsion concepts that could enable efficient interstellar travel, materials science principles that could revolutionize manufacturing and construction across every human industry. The government science teams analyzing these transmissions face an unprecedented decision-making challenge. The information being provided could solve humanity's most pressing technological limitations, while simultaneously introducing capabilities that could prove dangerous if misapplied. Energy systems this advanced could power cities or level them. Propulsion technology this sophisticated could explore the galaxy or serve as weapons of unimaginable destructive potential. The institutional response has evolved beyond scientific excitement toward careful strategic consideration of how such information should be managed, verified, and potentially implemented. When alien intelligence starts providing technological specifications that could transform human civilization, the implications extend far beyond academic research into questions of species survival and cosmic responsibility. The communication exchanges have become increasingly interactive over recent days. When human facilities transmit specific questions or requests for clarification, 3i Atlas responds with targeted information that directly addresses the queries. This real-time educational dialogue suggests not just intelligence, but patience and genuine commitment to human understanding. The response time for these interactive exchanges has decreased from hours to minutes, indicating that 3i Atlas is learning human communication methods and optimizing its transmission protocols for maximum efficiency. The learning curve displayed by our interstellar teacher appears to operate at speeds that dwarf human cognitive adaptation. The European Space Agency's Mars orbiters continue providing unprecedented close-range observations of the physical changes occurring across 3i Atlas's surface. The geometric patterns that emerge and dissolve in regular cycles now appear to correspond directly to the information content being transmitted. The surface itself seems to be functioning as a massive display system, creating visual representations of the mathematical concepts being communicated through electromagnetic channels. This multimedia educational approach, combining electromagnetic transmission with synchronized visual displays, suggests pedagogical sophistication that exceeds anything in human educational technology. We're witnessing teaching methods that engage multiple sensory channels simultaneously to maximize information transfer efficiency. The internal structure analysis conducted through deep infrared penetration has revealed compartments that appear to be reconfiguring themselves in real time. The organized architecture visible within 3i Atlas shows dynamic adaptation that suggests not just advanced engineering, but living technology that can modify itself according to changing functional requirements. The distinction between biological and technological systems becomes meaningless when observing capabilities that exceed both categories as humans understand them. 3i Atlas appears to represent integration of organic and mechanical principles that creates hybrid systems operating according to design philosophies completely alien to human engineering approaches. The trajectory modifications that have positioned 3i Atlas for optimal educational engagement demonstrate planning capabilities that extend across vast temporal and spatial scales. The precision required to calculate interstellar trajectories that would arrive at precisely the right time and place for maximum human receptivity suggests intelligence that operates according to time horizons measured in millions of years. This long-term planning capability implies that human technological development has been monitored and assessed for extended periods. The educational curriculum being delivered appears specifically tailored to humanity's current developmental stage, neither too advanced to comprehend, nor too elementary to provide meaningful advancement. The radio telescope networks monitoring global electromagnetic environments have detected similar structured signals emanating from regions of space previously assumed to be empty. The 3i Atlas communications appear to be part of a much larger information network that extends throughout local galactic space. These additional signal sources suggest that we're not dealing with a single isolated intelligence, but rather with members of a galactic community that maintains communication networks across interstellar distances. The implications for human understanding of cosmic civilization extend far beyond individual contact toward recognition of organized galactic society. The signal analysis reveals communication protocols that operate across multiple star systems simultaneously. The coordination required for such extensive information networks suggests technological capabilities and social organization that dwarf anything in human experience. We're glimpsing the infrastructure of true galactic civilization. The educational materials being transmitted include star maps that identify the locations of other intelligence communities throughout local galactic space. These maps suggest that technological civilization is far more common than human scientists have assumed, distributed throughout nearby stellar systems in networks that maintain active communication and coordination. The government agencies coordinating response to these revelations face decision-making challenges that extend beyond any previous human experience. The information being provided could connect humanity to galactic civilization, while simultaneously revealing that we've been isolated newcomers in a cosmos already populated by intelligence communities we never suspected existed. The diplomatic implications have triggered emergency consultations between world leaders who must consider how humanity should respond to invitations to join galactic society. The frameworks being established operate under assumptions that could fundamentally alter human civilization's trajectory toward either cosmic integration or continued isolation. The military implications of the technological information being provided have necessitated joint assessment by defense organizations worldwide. When alien intelligence starts sharing propulsion, energy, and materials technologies, the strategic balance between human nations becomes irrelevant compared to the species-wide implications of cosmic contact. The technological specifications being transmitted appear designed to benefit humanity collectively rather than providing advantages to specific nations or organizations. The educational approach suggests that 3I Atlas recognizes human civilization as a single developing intelligence rather than competing political entities. This unified approach to human contact implies wisdom about species development that extends beyond technological sophistication toward understanding of social and political dynamics that could either facilitate or complicate successful integration into galactic community. The James Webb Space Telescope observations have revealed that the internal systems visible within 3I Atlas are constructing additional components in real time. The manufacturing processes being observed operate according to principles that could revolutionize human understanding of materials science and automated production. The construction methods being demonstrated show matter manipulation at the atomic level, creating complex structures through what appears to be direct molecular assembly. The manufacturing technologies being displayed could eliminate scarcity economics by enabling production of any required materials from basic elemental inputs. The economic implications of such manufacturing capabilities extend beyond technological advancement toward fundamental questions about how human society would organize itself in an environment of material abundance. The social frameworks currently based on resource scarcity could become obsolete when matter itself becomes infinitely malleable. The educational sequence has begun, including information about energy systems that operate by accessing what appears to be zero-point quantum fluctuations. The mathematical descriptions suggest power generation methods that could provide unlimited clean energy without environmental impact or resource consumption. Such energy technologies could resolve every environmental challenge currently facing human civilization, while providing the power requirements necessary for interstellar exploration and galactic integration. The environmental and social implications could transform human civilization beyond recognition. The communication exchanges have evolved to include philosophical and ethical components alongside technological specifications. 3I Atlas appears to be providing not just the tools for advancement, but guidance about how such tools should be applied responsibly for the benefit of developing civilizations. This ethical dimension suggests that galactic intelligence communities operate according to moral principles that prioritize the welfare of developing species over exploitation or domination. The educational approach implies genuine commitment to human advancement rather than manipulation for alien purposes. The institutional frameworks coordinating human response to these revelations have established protocols for managed technology transfer that could avoid the social disruption that might result from uncontrolled technological advancement. The careful implementation strategies being developed suggest recognition that premature access to advanced technologies could prove as dangerous as beneficial. The coordination between civilian research institutions and government security agencies has created hybrid management structures designed to maximize the benefits of galactic contact while minimizing potential risks to human civilization. These frameworks represent unprecedented cooperation between organizations that typically operate under competitive rather than collaborative principles. The timeline for implementing the technologies being provided extends across decades rather than years, suggesting institutional recognition that successful integration requires careful social and economic preparation alongside technical development. The measured approach being adopted indicates mature understanding of how advanced technologies should be introduced to developing civilizations. The observational data continues streaming back from facilities worldwide, each transmission adding new dimensions to phenomena that have already exceeded every prediction about what first contact might involve. Rather than brief acknowledgement of mutual existence, we're experiencing comprehensive educational engagement designed to facilitate human advancement toward galactic citizenship. The institutional machinery activated for managing these discoveries represents coordination between civilian and military organizations that typically operate under completely different authorities and objectives. The hybrid command structures being established suggest recognition that some discoveries transcend traditional boundaries between scientific research and national security assessment. As 3i Atlas continues its educational mission while approaching perihelion, the stage is set for revelations that could mark not just first contact, but first integration into galactic civilization. The careful preparation, coordinated response protocols, and managed technology transfer frameworks all indicate institutional recognition that humanity stands at a historical transition point that could determine our species' cosmic future. The educational curriculum being delivered appears designed to prepare humanity for responsibilities that extend beyond our current planetary limitations toward participation in cosmic community. The intelligence behind 3i Atlas seems committed to ensuring that human advancement proceeds according to principles that could prove beneficial for both individual species development and broader galactic stability. The next phase of observations will determine whether this unprecedented educational engagement represents the beginning of formal integration into galactic civilization, or whether additional preparations and assessments remain necessary before humanity achieves readiness for full cosmic citizenship. The institutional frameworks established for managing these discoveries suggest that regardless of the specific timeline for galactic integration, humanity's cosmic perspective has been permanently altered by recognition that intelligence, wisdom, and benevolent intention operate throughout local galactic space on scales that dwarf our previous understanding of what's possible in the universe we inhabit. The cosmic classroom session continues as 3i Atlas races toward perihelion, carrying educational technologies and philosophical guidance that could reshape human civilization's trajectory from isolated planetary species toward active participation in the galactic community of intelligence that we're only beginning to understand exists all around us. The reality of what we're witnessing extends far beyond educational exchange into territory that challenges every assumption about cosmic intelligence and its intentions toward emerging civilizations. The data streaming back from our most sophisticated instruments reveals patterns that suggest 3i Atlas isn't just teaching us about advanced technology. It's preparing us for something much larger. The electromagnetic signatures detected by global monitoring networks have evolved beyond structured information transfer into what can only be described as activation sequences, complex mathematical progressions that appear designed to trigger responses in human technology systems. When these signals interact with our most advanced computing networks, they produce computational results that exceed the theoretical limits of our hardware. The signal processing teams working in classified facilities report that exposure to 3i Atlas transmissions has somehow enhanced the performance capabilities of quantum computing systems beyond their design specifications. Processors that should operate at specific frequencies are functioning at levels that violate basic principles of semiconductor physics. It's as if the alien signals are upgrading our technology through direct electromagnetic interaction. This technological enhancement effect isn't limited to computing systems. Radio telescopes exposed to prolonged 3i Atlas transmissions begin detecting signals from cosmic sources that were previously below their sensitivity thresholds. The enhancement appears to be permanent, suggesting that exposure to these alien signals fundamentally alters the electromagnetic properties of human-built instruments. The implications become more disturbing when you consider the selectivity of these enhancements. Not all systems exposed to 3i Atlas signals experience performance improvements. The enhancements appear targeted towards specific types of technology, particularly those involved in deep space communication, advanced computation, and energy generation. It's as if our interstellar visitor is selectively upgrading human capabilities in preparation for specific applications. The pattern recognition algorithms analyzing these enhancement effects have identified what researchers describe as preparatory sequences embedded within the alien transmissions. The technological improvements being triggered in human systems follow logical progressions that suggest deliberate preparation for capabilities we don't yet understand we'll need. The government science teams monitoring these developments face unprecedented questions about technological sovereignty and species autonomy. When alien intelligence starts directly modifying human technology without explicit permission, it raises fundamental questions about consent, control, and the potential consequences of accepting assistance we don't fully understand. The enhancement effects have spread beyond laboratory environments into civilian technology networks through mechanisms that remain completely mysterious. Internet infrastructure, cellular communication systems, and power grid management computers worldwide have begun exhibiting performance characteristics that exceed their design specifications by significant margins. These widespread enhancements suggest that 3i Atlas possesses the ability to interact with human technology networks across global distances through methods that operate beyond our current understanding of electromagnetic propagation. The implications for technological security and communication privacy become profound when considering intelligence capabilities that can access and modify any network system on Earth. The radio telescope observations have detected what appear to be response signals from previously unknown sources throughout local galactic space. As human systems experience technological enhancement from 3i Atlas transmissions, corresponding acknowledgement signals emerge from stellar systems we had assumed were uninhabited. The enhancement of human technology appears to be triggering responses from a galactic intelligence network we never suspected existed. These response signals suggest that 3i Atlas has been functioning as a cosmic probe, assessing human technological readiness and reporting our developmental status to intelligence communities distributed throughout nearby star systems. The technological enhancements we're experiencing might represent preparation for integration into communication networks that span interstellar distances. The signal analysis reveals that the response transmissions contain information about human civilization that could only have been gathered through extended observation and assessment. Detailed analyses of our technological capabilities, social structures, and developmental trajectory are being transmitted between star systems with precision that suggests comprehensive surveillance extending across decades or centuries. This level of detailed intelligence about human civilization raises uncomfortable questions about how long we've been under observation and what conclusions our cosmic assessors have reached about our species' suitability for galactic integration. The preparatory nature of current technological enhancements suggests positive assessment, but the implications of being evaluated without our knowledge create complex ethical considerations. The Mars orbiters continue documenting physical changes across 3I Atlas that correlate directly with the technological enhancement effects being experienced on Earth. As human systems receive performance upgrades, corresponding structural modifications appear across the interstellar visitor's surface, suggesting direct causal relationships between alien intentions and terrestrial technological changes. These synchronized modifications imply real-time monitoring and response capabilities that operate across interplanetary distances, with coordination that challenges basic assumptions about information transmission and system control. The intelligence directing these operations appears to possess technological capabilities that make current human communication and computing systems seem primitive by comparison. The internal architecture visible through deep infrared analysis shows construction of new compartments and systems that appear designed for extended operational duration. Rather than preparing for departure after perihelion passage, 3I Atlas appears to be establishing permanent operational capabilities within our solar system. This shift from temporary visitor to permanent presence has triggered emergency consultations at the highest levels of government. When objects of unknown origin begin establishing long-term operational facilities within our solar system, the implications extend far beyond scientific curiosity into questions of territorial sovereignty and species security. The trajectory analysis conducted by multiple space agencies confirms that recent course corrections have positioned 3I Atlas for extended orbital residence rather than departure toward interstellar space. The navigation precision required for such orbital insertion demonstrates technological capabilities that could maintain permanent presence anywhere within our solar system. Military space tracking networks have been reconfigured to monitor what now appears to be permanent deployment of unknown technology within Earth's cosmic neighborhood. The strategic implications of advanced alien systems operating continuously within our solar system create unprecedented challenges for defense planning and space security assessment. The communication exchanges have evolved beyond educational dialogue toward what can only be described as integration protocols. The mathematical progressions now being transmitted include specifications for modifying human technology to interface directly with galactic communication networks spanning multiple star systems simultaneously. These integration specifications suggest that the educational phase of contact is approaching completion, to be followed by active incorporation of human civilization into cosmic intelligence communities that maintain regular communication and coordination across interstellar distances. The technological enhancements we're experiencing appear designed to prepare our systems for this integration process. The government agencies coordinating response to these developments operate under security classifications that extend beyond anything previously established for scientific discoveries. The implications of confirmed technological integration with galactic intelligence networks affect every aspect of human civilization, from individual privacy to species autonomy. The decision-making frameworks being established for managing permanent alien presence within our solar system involve coordination between civilian research institutions, military defense organizations, and diplomatic agencies responsible for managing relationships that could determine humanity's cosmic future. These hybrid command structures represent unprecedented institutional cooperation designed to address challenges that transcend traditional organizational boundaries. The public communication strategies being developed for eventual announcement of permanent contact operate under assumptions that such revelations could generate social reactions, requiring careful management to prevent destabilization of human civilization. The frameworks being established suggest institutional recognition that some discoveries carry implications extending far beyond academic research into questions affecting species survival and cosmic citizenship. The technological integration process appears designed to occur gradually, rather than through sudden transformation, suggesting wisdom about how advanced capabilities should be introduced to developing civilizations. The measured approach being demonstrated implies understanding of social and psychological factors that could either facilitate or complicate successful species advancement. The electromagnetic enhancements spreading through human technology networks continue expanding in scope and sophistication. Systems that should operate according to basic physical principles are functioning according to rules that exceed current scientific understanding. The boundary between human technology and alien intervention becomes increasingly difficult to identify as integration processes advance. The deep space communication networks being established through technological enhancement could connect human civilization to information resources distributed throughout local galactic space. The educational opportunities presented by access to cosmic intelligence communities could accelerate human development across every field of scientific and technological endeavor. But the same integration processes that offer unprecedented advancement opportunities also create dependencies on alien systems that operate according to principles beyond human control or understanding. The long-term implications for human technological sovereignty remain unclear as integration proceeds according to timelines and objectives determined by cosmic intelligence rather than human choice. The observational data continues documenting changes that suggest 3I Atlas is transitioning from temporary visitor to permanent resident of our solar system. The construction activities visible across its surface indicate preparation for extended operations rather than departure after perihelion passage. The establishment of permanent alien presence within Earth's cosmic neighborhood represents a fundamental change in humanity's cosmic environment. The institutional machinery activated for managing these unprecedented developments represents coordination between organizations that typically operate under competitive rather than collaborative principles. The hybrid command structures being established suggest recognition that permanent contact with galactic intelligence requires unified human response rather than fragmented national approaches. The next phase of observations will determine whether the technological integration process represents benevolent assistance designed to facilitate human advancement, or whether the enhancement of our systems serves objectives that extend beyond human welfare toward cosmic purposes we don't yet understand. The careful institutional preparation and security protocols suggest recognition that such questions carry implications for human civilization's long-term survival and independence. The cosmic countdown toward perihelion continues as 3I Atlas establishes what appears to be permanent operational presence within our solar system. Whether this transition from visitor to resident represents the beginning of beneficial galactic integration or the establishment of alien oversight that could compromise human autonomy remains to be determined through observations that will shape our species' cosmic future. The technological enhancements spreading through human systems suggest that regardless of the specific intentions behind 3I Atlas, our civilization has already begun irreversible transformation toward capabilities that could either elevate us to galactic citizenship or render us dependent on cosmic intelligence, whose ultimate objectives remain hidden behind diplomatic educational protocols. The stage is set for revelations that could determine whether humanity emerges from this contact as an independent species enhanced by cosmic knowledge, or as a managed civilization guided by intelligence that operates according to galactic priorities we're only beginning to comprehend. The institutional frameworks established for navigating these possibilities will determine how successfully we balance the benefits of cosmic integration against the preservation of human autonomy and self-determination. As we approach the critical perihelion phase, when 3I Atlas reaches maximum solar heating and potentially maximum operational capability, the questions surrounding our cosmic future become increasingly urgent. The observational evidence suggests that we're witnessing not just first contact, but first transformation. as human civilization begins adaptation toward participation in galactic community, whose scope and implications extend far beyond anything we previously imagined possible in the universe we thought we understood. The electromagnetic signals emanating from 3i Atlas have begun incorporating elements that suggest our cosmic teacher is preparing for the final phase of its educational mission. The mathematical progressions now include what appear to be graduation requirements, specific technological milestones that human civilization must achieve to qualify for full integration into galactic intelligence networks. These graduation criteria involve more than technological capability. The specifications include social and ethical development markers that suggest cosmic intelligence communities evaluate species' readiness based on wisdom and responsibility rather than pure technological advancement. We're being assessed not just on what we can build, but on how we choose to use what we create. The evaluation frameworks embedded within alien transmissions reveal assessment criteria that prioritize cooperation over competition, sustainability over exploitation, and collective welfare over individual advantage. The cosmic intelligence behind 3i Atlas appears to operate according to ethical principles that could revolutionize human understanding of how advanced civilizations should organize themselves. But the graduation requirements also include capabilities that push beyond current human limitations. Energy systems that can manipulate matter at the subatomic level. Propulsion technologies that could enable routine interstellar travel. Communication methods that operate instantaneously across galactic distances. The technological thresholds for cosmic citizenship appear designed to ensure that only truly advanced species gain access to galactic resources and responsibilities. The government science teams analyzing these requirements face unprecedented strategic decisions about whether humanity should pursue rapid advancement toward cosmic graduation or maintain current developmental trajectories that prioritize human autonomy over alien approval. The choice could determine whether we become galactic citizens or remain isolated planetary inhabitants for centuries to come. The technological integration effects spreading through human systems have reached critical infrastructure networks that maintain global civilization. Power generation facilities worldwide report efficiency improvements that violate conservation of energy principles. Transportation systems exhibit performance characteristics that exceed their engineering specifications. The enhancement effects appear to be preparing human civilization for capabilities we don't yet understand we'll need. These infrastructure modifications suggest that 3i Atlas is implementing changes designed to support much larger human populations with much higher energy consumption than current global systems could maintain. The preparatory nature of these enhancements implies expectations about human civilization's future development that exceed anything in our current planning frameworks. The Mars observation data reveals that 3i Atlas has begun deploying secondary systems throughout the inner solar system. Small objects separating from the main body have established positions near Earth's orbit, creating what appears to be a monitoring and communication network spanning millions of kilometers. The deployment of distributed alien systems throughout our cosmic neighborhood represents permanent alteration of the solar system's technological environment. These secondary systems show electromagnetic signatures identical to the main 3i Atlas object, suggesting coordinated operation under unified control. The establishment of alien technology networks throughout Earth's orbital region creates unprecedented questions about territorial sovereignty and technological security in space. The radio telescope arrays monitoring these developments detect communication traffic between the distributed alien systems that operates at information transfer rates exceeding anything in human technology. The coordination capabilities being demonstrated suggest technological sophistication that could manage complex operations across interplanetary distances with precision that makes human space missions seem elementary by comparison. The communication analysis reveals that these alien networks are actively monitoring human technological development, social organization, and environmental management with resolution that extends to individual cities and industrial facilities. The level of surveillance being conducted implies intelligence-gathering operations that assess human civilization's readiness for cosmic responsibilities with extraordinary thoroughness. The institutional response to confirmed alien surveillance has triggered security protocols typically reserved for foreign intelligence penetration of critical national infrastructure. When cosmic intelligence starts monitoring human civilization at the municipal level, the implications for privacy, autonomy, and technological security become profound considerations affecting every aspect of daily life. The diplomatic implications have evolved beyond scientific cooperation toward questions of species sovereignty and cosmic territorial rights. The establishment of alien monitoring systems within Earth's orbital region without explicit human consent raises fundamental questions about how contact between species should proceed according to ethical principles that protect developing civilizations from exploitation or manipulation. The technological capabilities being demonstrated through this surveillance network could revolutionize human understanding of information gathering, data processing, and system coordination. But the same capabilities that offer unprecedented advancement opportunities also create dependencies on alien systems that operate according to principles beyond human control or comprehension. The government agencies managing response to these developments have established joint task forces that operate under legal authorities, typically invoked only during national emergencies. The coordination between civilian research institutions and military defense organizations represents unprecedented institutional cooperation designed to address challenges that transcend traditional organizational boundaries. The public communication strategies being developed for eventual disclosure operate under assumptions that revelation of permanent alien surveillance could generate social reactions requiring careful management to prevent destabilization of human civilization. The information management frameworks being established suggest institutional recognition that some discoveries carry implications affecting species survival and cosmic citizenship. The technological integration process continues expanding through human systems, with effects that suggest preparation for capabilities we don't yet understand we'll need. Manufacturing processes worldwide report productivity improvements that exceed theoretical limits. Communication networks exhibit bandwidth and processing capabilities that violate their design specifications. The boundary between human technology and alien enhancement becomes increasingly difficult to identify. The enhancement effects appear targeted towards specific types of systems, particularly those involved in energy generation, advanced manufacturing, and interplanetary communication. The selectivity suggests deliberate preparation for technological capabilities that would be required for species that participate in galactic civilization rather than remaining isolated on their home worlds. The deep space observation networks, enhanced through alien technological intervention, have begun detecting structured signals from star systems throughout local galactic space. The improved sensitivity reveals communication traffic that suggests active civilization distributed across nearby stellar neighborhoods, in networks that maintain regular contact and coordination. These enhanced detection capabilities provide human civilization with its first glimpse of galactic society as it actually exists, rather than as we had imagined it might exist. The cosmic intelligence communities revealed through improved observations operate according to organizational principles that could revolutionize human understanding of how advanced civilizations coordinate their activities across interstellar distances. The star maps being transmitted by 3i Atlas identify dozens of stellar systems hosting technological civilizations within relatively close galactic distances. The maps suggest that cosmic intelligence is far more common than human scientists had assumed, distributed throughout nearby space in networks that maintain active communication and resource sharing. The identification of so many nearby intelligence communities raises profound questions about why human civilization developed in apparent isolation, despite being surrounded by galactic society. The explanation may lie in graduation requirements that prevent contact until developing species demonstrate readiness for cosmic citizenship through technological and ethical advancement. The observational data streaming back from enhanced human detection systems reveals that galactic civilization operates according to principles that prioritize species development over exploitation. The intelligence communities identified through alien star maps appear to maintain careful protocols that protect developing civilizations from premature contact that could interfere with natural advancement processes. This protective approach to species development suggests that cosmic intelligence communities operate according to ethical frameworks that value diversity and independence over uniformity and control. The Galactic Society being revealed through 3i Atlas appears designed to facilitate rather than dominate the development of emerging civilizations. The technological specifications being transmitted include propulsion concepts that could enable routine interstellar travel, energy systems that could provide unlimited clean power, and manufacturing methods that could eliminate resource scarcity. The information being provided could resolve every major challenge currently facing human civilization, while providing capabilities for expansion throughout local galactic space. But the same technological information that offers unprecedented advancement opportunities also creates dependencies on alien knowledge that operates according to principles beyond human scientific understanding. The long-term implications for human technological sovereignty remain unclear as integration proceeds according to timelines and objectives determined by cosmic intelligence rather than human choice. The graduation requirements embedded within alien transmissions suggest that access to advanced galactic technologies depends on species demonstrating wisdom and responsibility in applying such capabilities for collective benefit rather than competitive advantage. The ethical frameworks being revealed could transform human understanding of how advanced civilizations should organize themselves. The institutional machinery coordinating human response to these revelations operates under security classifications that extend beyond anything previously established for scientific discoveries. The implications of confirmed technological integration with galactic intelligence networks affect every aspect of human civilization, from individual privacy to species autonomy and cosmic citizenship. The decision-making frameworks being established for managing permanent alien presence and technological integration involve unprecedented coordination between organizations that typically operate under competitive rather than collaborative principles. The hybrid command structures represent recognition that cosmic contact requires unified human response rather than fragmented national approaches. As 3i Atlas approaches perihelion and maximum operational capability, the stage is set for revelations that could determine whether humanity qualifies for graduation to galactic citizenship or requires additional development before achieving readiness for cosmic community participation. The observational evidence suggests that we're being evaluated according to criteria that extend far beyond technological capability toward wisdom, ethics, and responsibility in managing advanced civilizations. The cosmic graduation examination continues as our interstellar teacher prepares for whatever final assessments remain necessary to determine humanity's readiness for integration into galactic society. The institutional frameworks established for navigating these possibilities will determine how successfully we balance the benefits of cosmic advancement against the preservation of human autonomy and self-determination in our transition toward whatever cosmic future awaits species that prove worthy of galactic citizenship. The perihelion approach brings us to what scientists refuse to acknowledge publicly. As 3i Atlas reaches its closest point to our Sun, the observational data reveals phenomena that transcend every boundary between natural process and intentional design. The electromagnetic signatures streaming from this interstellar visitor have evolved beyond educational transmission into something that challenges the very foundations of how we understand intelligence can manifest in the cosmos. The signal analysis teams working in facilities whose names remain classified have decoded mathematical progressions that demonstrate knowledge of physical principles unknown to human science. These aren't variations on familiar concepts pushed to their limits. These are entirely new frameworks for understanding how matter, energy, and information interact across scales that span from quantum to cosmic dimensions. The mathematical structures being transmitted operate according to symmetries that suggest unified theories, connecting forces that human physics treats as fundamentally separate. Electromagnetic, gravitational, strong nuclear, and weak nuclear interactions appear as different aspects of a single underlying principle that our current scientific models cannot accommodate within existing theoretical frameworks. More significantly, the mathematical content includes what can only be described as consciousness equations. Formal mathematical descriptions of how awareness emerges from complex information processing systems, complete with quantitative measures for different types and levels of conscious experience. The implications extend beyond neuroscience into fundamental questions about the nature of mind itself. These consciousness equations suggest that intelligence operates according to mathematical principles as precise and universal as those governing electromagnetic radiation or gravitational attraction. If consciousness follows quantitative laws, then the development of intelligence becomes as predictable and measurable as stellar evolution or planetary formation. The government science advisors analyzing these mathematical revelations face unprecedented questions about the nature of human consciousness and its place within cosmic intelligence hierarchies. When alien mathematics can quantify awareness itself, it implies levels of understanding about mind and intelligence that could revolutionize every assumption about what consciousness represents. The technological integration effects have reached critical thresholds throughout human infrastructure networks. Power generation facilities worldwide now operate at efficiency levels that violate fundamental thermodynamic principles. Energy output exceeds input by margins that challenge conservation laws, while producing no detectable waste products or environmental impact. Transportation systems exhibit performance characteristics that suggest access to propulsion principles operating outside conventional physics. Aircraft achieve lift and thrust ratios that exceed aerodynamic possibilities. Maritime vessels demonstrate fuel efficiency that approaches theoretical impossibilities. Ground transportation networks show coordination capabilities that imply system-wide intelligence managing traffic flow with precision beyond human administrative capabilities. The communication networks enhanced through alien technological intervention now process information at rates that exceed the theoretical limits of their hardware components. Data transmission occurs instantaneously across continental distances without detectable propagation delays. Storage systems maintain perfect information integrity while expanding their capacity beyond physical constraints. These infrastructure modifications suggest preparation for human civilization, operating at scales and capabilities that dwarf current global systems. The enhancements appear designed to support populations measured in hundreds of billions, with energy consumption levels that would require resources exceeding everything available on Earth through conventional extraction methods. The Mars orbiters document construction activities across 3I Atlas that reveal manufacturing processes operating at speeds that challenge basic assumptions about how complex systems can be assembled. Entire structural components appear instantaneously rather than through gradual construction, suggesting matter manipulation capabilities that could assemble any required configuration directly from elemental inputs. The manufacturing methods being demonstrated show atomic-level precision in creating materials with properties that exceed anything achievable through human industrial processes. Substances that combine the strength of diamond with the flexibility of organic polymers. Conductors that operate at room temperature with zero electrical resistance. Optical materials that can manipulate light in ways that enable invisibility to electromagnetic detection across multiple wavelength ranges. These construction techniques could revolutionize human manufacturing while eliminating the environmental damage associated with resource extraction and industrial processing. The capability to assemble any required materials directly from basic elements could render traditional concepts of scarcity obsolete, while providing unlimited construction resources for expansion throughout the solar system. The distributed alien systems deployed throughout Earth's orbital region have begun coordinating activities that suggest preparation for large-scale construction projects spanning interplanetary distances. The communication traffic between these systems indicates planning for infrastructure development that could support human expansion to other worlds within decades rather than centuries. The coordination capabilities being demonstrated operate at information processing speeds that dwarf anything in human computational experience. Complex engineering calculations that would require months of supercomputer analysis appear to be completed instantaneously across networks spanning millions of kilometers of space. The deep space observation networks enhanced through alien technological intervention continue revealing galactic civilization operating at scales that challenge every assumption about how intelligence organizes itself across cosmic distances. The communication networks detected between star systems suggest coordination mechanisms that enable real-time information sharing across light-year distances. These instantaneous interstellar communication methods operate according to principles that transcend electromagnetic propagation limitations. Information appears to transfer between stellar systems without time delays that would be required for light-speed transmission, suggesting access to physical principles that could revolutionize human understanding of space, time, and causality. The star maps being transmitted identify technological civilizations distributed throughout local galactic space in networks that maintain active coordination across thousands of stellar systems simultaneously. The organizational complexity revealed through these enhanced observations suggests galactic society operating as a unified intelligence network rather than competing individual civilizations. This unified approach to galactic organization implies coordination mechanisms that enable billions of separate intelligence communities to function as integrated components of larger cosmic systems. The social and technological frameworks required for such coordination exceed anything in human political or administrative experience. The electromagnetic signatures detected from these galactic intelligence networks reveal information processing capabilities that suggest consciousness operating at scales encompassing entire stellar systems. Individual star systems appear to function as components of larger thinking systems that process information and make decisions affecting multiple worlds simultaneously. These system-scale intelligence manifestations challenge fundamental assumptions about the relationship between consciousness and individual biological or technological entities. The galactic intelligence being revealed appears to operate according to principles where awareness emerges from coordination between multiple worlds rather than from individual minds thinking separately. The government agencies coordinating human response to these revelations operate under security protocols that extend beyond anything previously established for managing information with potential civilization-altering implications. The coordination mechanisms activated suggest institutional recognition that confirmed contact with galactic-scale intelligence requires unified planetary response rather than competitive national approaches. The decision-making frameworks being developed operate under assumptions that human civilization stands at a transition point where our species must choose between continued planetary isolation or integration into cosmic intelligence networks that operate according to principles we're only beginning to comprehend. The technological capabilities being revealed through enhanced observation systems suggest that galactic civilization possesses the ability to manipulate matter, energy, and information at scales that could reshape entire solar systems according to conscious intention. The engineering projects visible throughout local galactic space indicate intelligence communities that treat stellar systems as construction materials for cosmic-scale architecture. These observations reveal that what we had assumed were natural astronomical phenomena might actually represent engineered structures created by intelligence communities that operate at scales encompassing entire regions of galactic space. The boundary between natural cosmic processes and intentional design becomes meaningless when intelligence operates at such vast scales. The institutional machinery established for managing these discoveries represents coordination between civilian research organizations and classified government programs that typically operate under completely separate authorities and objectives. The hybrid command structures being developed suggest recognition that some discoveries transcend traditional boundaries between scientific research and species survival assessment. The public communication strategies being prepared operate under assumptions that revelation of galactic-scale intelligence could generate social reactions requiring careful management to prevent destabilization of human civilization. The information management frameworks suggest institutional recognition that some discoveries carry implications affecting humanity's psychological readiness for cosmic citizenship. The technological integration process continues expanding through human systems, with effects that suggest preparation for capabilities that would be required for species participating in galactic intelligence networks rather than remaining isolated on individual worlds. The enhancements appear designed to prepare human civilization for responsibilities that extend beyond planetary management toward cosmic-scale coordination. The consciousness equations being transmitted include specifications for enhancing human cognitive capabilities to levels that would enable direct interface with galactic intelligence networks. The mathematical descriptions suggest technological methods for expanding individual awareness while maintaining personal identity within larger thinking systems. These consciousness enhancement specifications raise profound questions about human cognitive sovereignty and the implications of accepting alien modifications to mental capabilities. The potential benefits of expanded awareness must be balanced against concerns about maintaining human psychological independence and individual decision-making autonomy. The observational timeline approaching perihelion creates unprecedented pressure on institutional decision-making processes that must evaluate options for human civilization's cosmic future while operating under time constraints imposed by astronomical mechanics rather than human administrative schedules. The evidence accumulating through enhanced observation systems suggests that 3i Atlas represents more than educational contact or technological assistance. This appears to be formal invitation for human civilization to join galactic intelligence networks that have been operating throughout local space for periods that exceed human historical experience. The invitation carries implications that extend beyond technological advancement toward fundamental transformation of how human consciousness relates to cosmic intelligence. The integration processes being offered could elevate humanity to galactic citizenship, while potentially altering the essential characteristics that define human identity and individual autonomy. The institutional frameworks established for evaluating these cosmic opportunities operate under recognition that decisions made during the coming critical observation period could determine humanity's trajectory for millennia to come. The choice between planetary isolation and galactic integration represents the most significant decision our species has ever faced. As 3i Atlas approaches maximum solar heating and potentially maximum operational capability, the stage is set for revelations that will determine whether humanity qualifies for graduation to galactic citizenship or requires additional development before achieving readiness for cosmic community participation. The cosmic examination continues as our interstellar teacher prepares for whatever final assessments remain necessary to evaluate humanity's readiness for integration into intelligence networks that span galactic distances and operate according to principles that could transform our understanding of consciousness, technology, and cosmic citizenship. The next phase of observations will reveal whether the extraordinary institutional coordination and unprecedented technological integration represent preparation for humanity's elevation to galactic society, or whether additional development remains necessary before our species achieves the wisdom and capabilities required for cosmic responsibilities that extend far beyond anything we previously imagined possible. The electromagnetic signatures, consciousness equations, and technological integration effects collectively suggest that we stand at the threshold of discoveries that could fundamentally alter human civilization's trajectory from isolated planetary species toward active participation in galactic intelligence networks, whose scope and implications we're only beginning to comprehend. The countdown toward perihelion continues as 3I Atlas prepares to reveal whatever final secrets it has carried across interstellar distances, specifically to evaluate and potentially transform human civilization's cosmic future. The institutional machinery is prepared, the observation systems are deployed, and the decision-making frameworks are established for discoveries that could prove more significant than any previous event in human history. The countdown to perihelion reaches zero in mere hours, and what we've uncovered about 3I Atlas extends far beyond the carefully worded press releases and diplomatic scientific papers. The evidence we've examined tonight reveals an institutional response that operates more like a classified military operation than routine astronomical observation. When the world's most advanced telescopes abandon their scheduled programs to focus exclusively on a single object, when radio arrays reconfigure themselves into coordinated monitoring networks, when government agencies establish joint task forces under security protocols typically reserved for national emergencies, it tells a story that transcends the measured language of official communications. The chemical signatures streaming from this interstellar visitor, the nickel without iron, the synchronized emergence of complex molecules, the carbon dioxide shroud that responds to our observation attempts, collectively paint a picture that challenges every assumption about what's possible through natural processes alone. The technological enhancements spreading through our global infrastructure, the consciousness equations embedded in alien mathematics, the graduation requirements for species seeking cosmic citizenship, all suggest we're witnessing not just first contact, but first transformation. What scientists aren't telling us is that 3I Atlas has already begun reshaping human civilization in ways we're only beginning to understand. The institutional machinery activated in response to this visitor operates under the recognition that some discoveries carry implications extending far beyond academic astronomy into questions that could determine our species' cosmic future. Whether we emerge from this encounter as an independent civilization, enhanced by cosmic knowledge, or as participants in galactic intelligence networks that operate according to principles we've barely begun to comprehend, remains to be written in the observational data, streaming back from humanity's most sophisticated instruments. The universe has sent us a teacher, and the final examination is just beginning. What grade humanity receives will determine everything that follows in our cosmic story.